হ্যালো, শোনা যাচ্ছে শোভন?
হ্যাঁ, শোনা যাচ্ছে।
আচ্ছা,
লাইভ
বলবো।
স্টার্ট হয়ে গেছে।
ওকে, গুড মর্নিং এভরিবডি and welcome to the 2 days international webinar on emerging trends and advances in machine learning, organized by the Department of Computer Science and BCA, Debra Thana Shohid Khudiram Smriti Mahavidyalaya, paying obeisance to
স্যার, এক মিনিট এক
the
মিনিট এক মিনিট একটু wait করুন। এখনো সবাই জয়েন করছে, একটু একটু টাইম নিয়ে নিন।
okay. Department of Computer Science and PCA, Debra Thana Shohid Khudiram Smriti Mahavidyalaya is organizing 2 days international webinar on emerging trends and advances in machine learning today and tomorrow. Our participants can hear and watch us on YouTube, where we are live streaming the webinar. International webinar on emerging trends and advances in machine learning today and tomorrow. Our participants can hear and watch us on YouTube, where we are live streaming.
সোমো ভয়েস আসছে না, কিছু সমস্যা হচ্ছে। সৈকত বাবুর কোনো শোনা যায়নি, কোনো টোটাল ব্যাপারটা কিছু সেটা আমার এদিকে কিনা সেটা আমি বলতে পারবো না। তোমরা তোমরা কি শুনতে পাচ্ছ? ভয়েস অডিও কি আসছে?
আপনি শুনতে পাচ্ছেন ম্যাডাম?
এবার শুনতে পাচ্ছি, আগে শোনা যাচ্ছিল না।
ও আচ্ছা আচ্ছা, ঠিক আছে।
হ্যাঁ বলুন বড়বাবু।
গুড মর্নিং এভরিবডি and
আমরা তো প্রোগ্রামে
welcome
রয়েছি, এখন পরে কথা বলছি। হ্যাঁ,
and welcome to the 2 days international seminar webinar on emerging trends and advances in machine learning, organized by the Department of Computer Science and BCA, Debra Thana Shohid Khudiram Smriti Mahavidyalaya, paying obeisance to the great revolutionary who was martyred on the 11th of August 1908 at the age of 18, Khudiram Boshu. We set out on our 2 days journey. We are honored to have with us Sri Boibhav Choudhury, IAS, SDO Kharagpur, administrator of our college, as well as chief patron of this webinar. Dr. Rupa Dasgupta, principal of our college and chairperson of the organizing committee of this webinar, and distinguished guests, speakers, and experts. It gives me great pleasure to extend to all of you a very warm welcome on behalf of the Department of Computer Science and BCA of our college. There are participants from different colleges and universities, without whose participation the webinar would have been meaningless. A hearty welcome to all of you. Now I request Dr. Rupa Dasgupta, principal of our college and chairperson of the organizing committee of this webinar, to deliver her welcome speech. Madam, please.
Thank you, Shoykot Babu. Good morning to all of you. I can see that Sri Boibhav Choudhury, administrator of the college, SDO of Kharagpur, has joined. I thank him for his kind presence in the inaugural session of the two-day international webinar on emerging trends and advances in machine learning, which has been organized by the Departments of Computer Science and BCA of our college in collaboration with IEEE Computational Intelligence Society, Kolkata chapter. We are all aware of the current situation that we are in this current situation where what we call the new normal situation. Webinars have replaced the conventional seminar, conferences, and workshops that we are very well acquainted with working in higher education institutions. We organize, we participate seminars and conferences. Though in true sense, seminars or workshops cannot be replaced by webinars as the physical interaction is lacking. But we have to accept that webinars give us a platform to interact with the prominent academicians who are established in their field, get us a chance to listen to them and interact with them in a digital platform. So this initiative has been taken by our departments, and the technical sessions, the speakers, they have been carefully scheduled. Today itself, we have 2 technical sessions, 4 speakers coming from IIT Kharagpur, they're coming from NIT Durgapur. PhD researcher, a prominent PhD researcher is coming from an university of Sweden, and also an eminent professor from Department of Computer Science, Vidyasagar University, will be delivering their addresses. We have kept an interaction session for all the speakers, and also tomorrow we have 2 technical sessions where 3 speakers will be delivering their addresses coming from Vidyasagar University and also from Bhubaneswar. From the data that I have got from yesterday's report, nearly 550 participants have registered. This program is kindly live on YouTube, and participants are students, researchers have joined in the YouTube live streaming. And the most interesting part of it is nearly 100 of them are teachers, some are researchers, some are students, and they are coming from 16 different states of our country. That is very encouraging for us, that we have got quite a diverse and different participants from different fields, even officer in charges, teachers, researchers, students. So it's a very encouraging sign for us. I must thank Professor Paumartha Datta, Chair IEEE Computational Intelligence Society, Kolkata, for extending their technical collaboration for conducting this webinar. On behalf of the organizing committee of this webinar on emerging trends and advances in machine learning, I welcome all who will be joining later on, who have joined and who will be joining later on as speaker, as participants. I thank all of them for their kind cooperation in conducting this program. I also thank Sri Boibhav Choudhury for always supporting and encouraging us so that we can move on and do some small but new things that are not usually we do not do in our college, since our college is a new college, as Professor Chakraborty has already said. So we are trying to do things, academic things, other than teaching and learning. Especially in this current situation, organizing webinar is just a part of these academic activities. I once again welcome all of you. Thank you.
Thank you, madam. You have always encouraged us to seek knowledge and ways of imparting that knowledge to our students and society at large. Thank you very much. Now, may I request Sri Boibhav Chaudhuri, IAS, SDO Kharagpur, and administrator of our college, as well as chief patron of this webinar, to deliver his speech and officially inaugurate the webinar. Sir, please.
Good morning, everyone. I hope you all can hear me.
Yeah.
Thank you very much for inviting me to this webinar today. I joined the service in 2016, and this was my first posting in Kharagpur. When I joined, I was told that I'll be administrator of a college. I really have no idea how college systems run, but I'm very happy, and I would like to mention it, specifically say that in the last 1 year, I have seen a lot of things improve and a lot of systems change under the guidance of Dr. Rupadas Gupta, principal of our college. And this webinar is a small part of such initiatives, such small improvements that are taking our college to new heights. I worked in the private sector for 2 years. I was in Sony Corporation in Tokyo. So from that experience, I can say that the world of technology is changing very fast. When I was working, that was around 10 years back, 8 years back. Already they used to say that the product cycle of any new product, any new mobile phone or any new product has been reduced to nearly 6 months, just 6 months. From the day of conceiving the idea, to the day of it getting manufactured and delivered in the market, it takes just around 6 months in today's time. I'm sure it is reducing even further, and in future times it's going to reduce even more. So sessions like these, seminars like these, which take us beyond our normal curriculum and expose our students and professors and faculty to the new paradigms of technological advancements and shifts that are continuously happening, is very important for preparing all of us as a collective unit to be ready to face the challenges of the real world as our students step out in the professional society and world. I understand that during these times, the physical interaction is lacking and classes are not happening, but I'm very happy that such webinars are being organized. And that's why when yesterday Principal Ma'am told me that I have to be here at this time, I made sure that I'm here. Even though I have a meeting, I'll very soon be leaving. I'm also very happy to see that there's a wide range of participation. A lot of students are here, and faculty members and professors from various different institutes are here to give their expert insight into the field of machine learning. I'll not take much of your time. I'll just want to congratulate you all on this new initiative and also wish you all the best of luck. Please enjoy your day, enjoy learning through these sessions, and may it be of great use to you in your future. Thank you.
Thank you, sir.
Thank you, sir. Thank you very much. We know how busy you are, particularly in these difficult times. Yet you have spared some of your time for us and shared with us your thoughts. Thank you very much. We all know what we have been going through for more than 5 months or so. However, the prospect of getting an exposure to what our distinguished speakers and experts discuss on this very interesting topic can turn away our despondent minds from the gloom to the light. Here we end the inaugural session. The first technical session will follow. will start in a few minutes, and Mr. Joydev Dey, Assistant Professor in Physics of our college, also Secretary of the organizing committee of this webinar, will take over. Please, Joydev, over to you.
Yes, sir. Good morning to all. In our first technical session, our speaker, Dr. Devdut Sikh. He is the Assistant Professor, Department of Electrical Engineering, IIT Kharagpur, also founder of Skin Curator Research. He have done BTech in Electronics and Communication Engineering, West Bengal University of Technology, Kharagpur, Kolkata, 2008. ME in Mechanical Science and Technology from IIT Kharagpur, 2010. He have done his PhD from IIT Kharagpur, 2014. During his PhD, he contributed many developing suites for the society. He also a DAT alumni and also a DAT fellowship from Germany. Today he will discuss the deep learning or mathematics of the learning. Sir, please tell about your speech about mathematics of the deep learning.
Thank you. I really thank the organizing committee for inviting me. And this is quite an intriguing and interesting time to be over here. If this wasn't possibly this kind of a trying out time, I would have loved to be over there in the college in person. But nonetheless, now it's better that we continue with our new normal, which has almost started becoming the normal thing of stay for us. So what I'm going to speak about today is some of my experiences with machine learning, and I typically work in the area of what is called as deep learning, but I will not be just jumping into the topic because I did look through the whole program, and what seemed to me as would be quite natural is to take you on sort of a storytelling journey on how things have evolved over this period of time, and how this whole evolution has shaped how we look into the world and how products come out. So in fact, like we had a patron, Beva Chaudhary IAS, telling about the whole experience which he had while he was in Japan on his professional career, that technology changes in the span of 6 months. And that's essentially what we are looking into it. So in fact, research is also too competitive in the whole field because we end up having a complete massive transformation, a problem which you would see typically, which is unsolvable today. In the next 6 months, you would have seen that there is a plethora of solutions available in the same area. And research has become quite democratic. You have very easy access to knowledge. And that makes it, on one side, challenging, and on the other side, an opportunistic scenario as well. So at the start of it, I try to keep my talks quite interactive so that people don't end up sleeping. And I also have a timekeeping with me so that we don't get bored in 20-25 minutes. So there would be a lot of quizzes inside. And since I see people are live as well on this one, so maybe you can actually type on your comments the answers or some things which you would like to really tell me. And that would be quite nice. Now, to start with this one, this is the first quiz, and on my former role as a member of faculty in the Department of Electrical Engineering and the Center for Artificial Intelligence, this is something which I'm pretty much used to doing. I start with a quiz, and this does not need a prerequisite. So what you can do is you can either write down as left or right on the chat box based on which of these you think as being the original image. So let's take 2 minutes. I believe we have time for doing this exercise. There is no prizes. There are no penalties. So you can just write down based on seeing this particular image, whether you think the one on the left is original or the one on the right is original. Left, okay, good. So we got one left supporter. Come on, write down something. You can just write on the chat. Okay, the second one also says left. I hope that people are not just copying the previous one over there. Yes, now I get down somebody who says right. Let's see.
Sir, most one from audience section is telling left.
Most in the audience section is telling left. How many are telling right?
Yeah.
If we can have just the count, I want to do a histogram in front of you guys.
Sir, only 4 members from audience section is telling right side.
Okay.
It's right.
So right I have in total 6 and left I have 6. So
Sir,
let's
more than 6 from audience section. There are more than 6.
Left, how many people are telling on audience?
Sir, more than 13 people are saying that the left image is right.
1 3 13 1 3 or 3 0.
Yes, 13.
Okay.
Yeah.
Okay. So of this poll, I have 24 people who have responded. 18 said it is left and 6 said it is right. So there is still some sort of an uncertainty. So essentially the probability that the left one is the original image is 18 by 24. That makes it 3 by 4. And the probability that the right one is the original image is 6 by 24, or what makes it 1 by 4. Now that is quite an intriguing one. So I will not tell you the answer right now. I will tell you the answer sometime later on, though we don't have this image. Or maybe I can just tell you the answer to make you quite interested. So actually the right one is the original image. The left one is not the original image. The left one is something which was generated by this computer over here, and there was a pure machine learning algorithm which was used in order to generate. So that should sort of like create a quite conflict within you as to why that had happened. But there are actually clues in the image which, because I've been working on this one with these kind of images for more than a decade now, I can pretty much easily look at the image and spot out what were the clues. But Nonetheless, this was a good try, and we did fool most of the people to believe that whatever was generated by a machine learning was actually generated by an actual system. So that's the win of my system over here. So from my research, I would really be happy that we have been able to fool people to believe that anything which comes out of research was actually coming out from an original machine. Now, there are pros and cons of this one. We'll not get into a societal debate and ethics debate around that. That doesn't really help anybody. But the power is over here that today we have been able to make machines that intelligent, that they are able to really understand physics of processes. And in fact, what machine learning was getting used over here, all of this was trying to model a very high order nonlinear random system in order to be able to replicate the complete stochastic mechanics of that system. So this is a very, very complex process which was happening, and we have been able to do that with machine learning, and that's one of the triumphs. And then in fact, this has been the starting point of where in the world we are thinking of using these kind of advanced techniques in order to come up with the next level of understanding and explanation. And the next level of understanding and explanation in terms of, can we really, really demystify and clarify the complete system understanding? Or can you now have theorems of physics and lemmas and an hypothesis written down by machine learning systems themselves? So this is really that interesting part which you will be seeing out now. So today I did say that I would be speaking on mathematics of deep learning, but then I realized that being the speaker on the first session, it would be wise to actually start speaking more on what I would call as transcendenting from human intelligence to artificial intelligence. Okay. So I think there was some disruption with my slide. I guess my slide is visible now to everybody.
Yes, sir.
Okay, yeah. So essentially today we are going to speak on this particular topic, which is of quite interest. And this is based on a lot of years of experience which I had on different forums, and a lot of people who actually funded and sponsored all the research which went into saying what we are going to say today, and listen to all of this. And this slide is basically my acknowledgement and thanks to all people, and also to the audience, saying that I have conflicts and I have interest with all of these entities over here, which spans from governments to industries to self-interest and everything. And this, whatever I'm speaking, is purely based on my experience. Maybe they don't relate to textbooks, and but I would try to bring things as closer to textbooks as possible to the maximum available time. So let's get into the point. Now, the first point is essentially this definition of what we call as learning. Now, if you look into this definition, learning is going to be a very general definition. I'm not going to stick myself to whether this is machine learning or this is human learning or anybody. And in fact, we are going to start with this definition looking at it from the perspective of a human as well. Though it says that in the perspective of a computer program, which is basically the crux of machine learning, is that a computer program will be said to learn only with respect to a certain thing which is called as experience, and for a certain class of task which is called as T, and you measure all of this based on the performance measure called as P. And now it will learn only if you see that the performance here P for performing a certain task T keeps on increasing or improving as it improves and increases on its experience called as E. So this is what is a definition which is given by this gentleman, Tom Mischel, who wrote down a very thin book. So the book is called as Machine Learning. The size of the book is something like Penny Madhov Fulpunjika. It's that small. It has about 15 or 16 chapters over there. But then this book has been more of what you can call as looking into the future of machine learning. So whatever was written in this book, we are actually living it ages by ages in a time. So today we are in the era of deep learning, which is somewhere on the 14th chapter, and then you have 2 more chapters. So essentially for people like me, I don't even know what will happen after those 2 more chapters will get expired, whether there will be anything more to do on machine learning or whether machine learning will completely go off. I don't know. Maybe quantum computing takes over and quantum learning takes over. We start looking into the next transcendental aspect itself. So that's a curious thing to look into it. Now that you have this wonderful definition in front of you on the screen, the question to people is, and you can unmute yourself and say, or you can write down on the chat or anything, is, does this really make sense? And are you able to really demystify and make anything out of it? You don't have to fake. You can clearly say that I did not understand anything, whatever you said over here. If you want to say it, just say it outright. I mean, unmute yourself and say it outright that we do not understand anything of this sentence. Or if you have understood, then you can also tell about your interpretation of this particular statement over here.
Sir, till now, we have not received the participant response.
So that essentially means that people have not understood, but we are generally very polite who do not wish to say it upright to the person saying this, like, I did not understand. And we generally tend to think that it is my fault if I did not understand, and it is not a fault of the person who is speaking in front of me, as if like that person is the gold standard reference of a god. Devoraj Indro chole eschen, uni kichu bhul korte paren na okhane. That's not going to happen. You have to keep on telling me. So I have one question on the chat, which is interesting, which says how performance is measured. Yes. Now keep this question in mind. We will actually come back to that. So all of my talk, the reason I'm asking you these questions is that keep those questions glued. And in fact, I will come back through this set of slides over here telling you exactly those points. So in fact, I'm noting it down. I have a small notepad over here on which I keep on noting it down. So first question is, how is performance measured? Any more questions? Let's see from this statement, whatever you are not able to understand.
No, sir. I think they have not replied till now.
Mm-hmm. Okay, so there is only one particular question. Okay, great. We will stick only to this one question, and I will show you the answer for that one. But please keep it interactive. I know that it will take time for you to break out of this, and most likely you might not even. So you break out of this in my session, and maybe for the next session again the speaker says that don't ask me questions till I end it. So that's perfectly up to a personal choice. In fact, my choice is that you keep it interactive. Otherwise, I feel sleepy while speaking after a lot of pain. So let me give you this interesting question over here. Now I know the location of your college, and there is something interesting which happens around your college, which is on the roads you will see cows and cars, trucks, minivans, matadors, everything, trekkers, everything present together. Okay. And now if I give you this interesting question, or this may be given down by your Gram Panchayat or somebody, and to students, faculties, researchers, innovators, inventors, whatever you call them, entrepreneurs as well. And the question is very simple. Can you tell me by some measure if whatever object is located on the road now is a cow or is it a car? Okay. Now look into the problem. The problem is that more or less the length of a car, length of a cow are the same. So they are all sort of like 6-7 feet wide. This is one problem. The other problem is if you measure the height, more or less they will be of the same height. And on top of it, if you try to measure something which is like what is the shade of color. So cows can be anything between white to black, including all the spectrum of colors available. So typically red is what you will get down, red, brown, all of this is what you will get down. And in fact, cars will also be of the same. So if you look into the black and white image, or what we call as a grayscale image, you would see that the luminous intensity, or the total amount of light which is reflected, that's also more or less the same for a cow and a car. And the only possible way you can discriminate is if you have a photograph, a picture over there. But if I don't give you a picture, I tell you that you cannot put a camera or something, but you will have to measure with some very small, simple sensors. And if you know about some of these microcontrollers and kits like Arduinos, then you know that there are sensors from which you can measure what is the shade of color, what is the length of an object, and all of this. Now, if you want to do all of this and then tell me, then what are you going to do? What will you do at the start of it? So let me tell what I would have done. And essentially, actually, I did it at one point of time. I took down a bunch of students and said, like, see, let's go on the road and let's actually do this experiment. It was quite risky at a point of time as well, because our idea was to take a tape and actually measure a cow. Measuring a car is easy because on the website of the company, you always get what is the size of a car. But measuring the size of a cow is not so easy because they don't go with Aadhaar cards which have biometrics on what is the height of a cow. So now we had to actually go with a tape and measure, and all the kicking and adventure which a cow will typically do was also part of the learning experience, and we loved and enjoyed it. So what we did over there was something like this. So we took a spot and we actually counted cows, and then we counted and we measured all of this. And now what I have on this plot over here is essentially there is an icon which looks like a cow or like a car, and this is more or less like whatever that actual object was. And I placed this one closer to the actual XY coordinate. So my X1 or the X-axis over here is basically what is the shade of color or how bright or dark it was. If it was very bright, then it is near 0. If it is very dark, then it is far off on the other side of it, or a value of 1. That is what I call as shade of color. And the other side is the length of this particular object, which is my y-axis, or what I also call as this vector representation called as x2. Okay. Now, the idea was that if from this measurement somehow I am able to solve this equation on the left-hand side, which is what we call as Bayes rule in very simple terms. So what a Bayes rule will do is that given you know what is the likelihood and what is the prior probability and the evidence of something happening, you can always come and tell me what is the posterior probability. And based on this probability, we shall be able to tell about something of this sort, which is called as a map rule. So a maximum a posteriori rule essentially says that whichever class, whether it's a cow or a car, whichever has the higher probability, you tell that this belongs to that particular class. So if it's a higher probability of there being a cow, you tell that there is definitely a cow over there corresponding to this measurement. If there is a higher probability of there being a car, then you say that it's essentially a car. So now, as a result of this, what you would get down is sort of like this kind of a color boundary, which I have in red plotted over on this small scatter plot with cows and cars. And this boundary is what is called as a decision boundary, and that is one of these crux problems which we try to solve in machine learning. So what we are trying to do is come up with this decision boundary. What is that point above which you would say that this is always a car, and below which you would say that it is always a cow? And that will happen because you use a argmax kind of a rule over here, saying that whichever is maximum, so anything, if you have a probability something like 0.51 and 0.49, your maximum is still 0.51, and then that is for the car. Versus if you have a probability like 0.9 and 0.1, so 0.9 being for the car, then also it's a car. So essentially anything on that side is totally a car, and anything on the other side is totally a cow over here. So this is essentially what we were trying to solve. But then this is not so trivial, what we were trying to do. Okay. So there comes down this point of what I would ask you is that I essentially have what is called as a set of data. And from there I have to go and make down some sort of statistics. So how do we start by doing that? This is the first question which we are going to solve. Okay. And in fact, for all of this, whatever maths we are going to do is something which is from your generally from your +2 syllabus. So you have done mathematics in your class 11 and 12, and this is essentially from that, and then nothing beyond it. Whatever we do today of modern statistics, machine learning and everything, the root is still only in school education mathematics. And honestly, if you ask me, whatever maths we do after that is really fanciful, and you can always learn everything given that you have really a very strong grasp of whatever you have done in your class 11 and 12. Not that complicated stuff in any way. Okay. So I will get down from this Bayes rule over here. Now we know Bayes rule in this particular format, and there is another derived format which you have over here. And typically on this particular one, what we have is one term which is called as posterior probability. Now, if you look into this particular equation, then you would see a term called as omega, this capital omega. Now this capital omega is what we call as the variable which denotes a particular class. Small omega is essentially a class label. So what we are saying is, what is the probability that the predicted class is equal to a certain class? So this is a variable and this is a constant for me. So this variable over here is something which says that whether it can either be a car or a cow, but that is a decision which has to be taken. Now you are going to take this decision based on certain input, and that is a class conditioning which is needed to be present. That class conditioning over here is essentially this X. So what this class conditioning says me is that given that your measurements of features or something is this particular part over here, then what is the chance that you are going to have a certain class corresponding to that? Now that is something which you can solve using this set of equation over here, where the first thing which you will need is what is called as likelihood. Now likelihood has the conditioning which is sort of inverse of what is the sort of conditioning in posterior probability. So here what I'm saying is that what is the probability of getting a certain feature if it belongs to a certain class. This is what I'm indicating essentially over here. Okay. So this thing is what we call as a likelihood, and we will get into solving like how do you really obtain a likelihood. This other thing is what is called as a prior probability, and what this prior probability indicates is what is the probability that you can have a certain class. And the other part is what is called as an evidence, which essentially indicates that what is the probability that a certain feature can exist, or this essentially says that what is my probability that an event can occur. So if an event does not occur, then it can not work out at all. Now the question which I have over here is, how will you really solve this equation given that I give you a bunch of data which only says that I have measurements corresponding to certain things, and I say that these are all cars or these are all cows. So now this is what we are going to solve. So first and foremost, where we will start is this whole art of counting, or what we also call as in a much more mature stage as a histogram. And from there we will come into the whole concept of a distribution model. Now you might have heard about distribution models, histograms and everything. If you have heard about histograms and distributions, you can just write down. I believe histogram everybody had studied sometime in your class 9, 10, 11, 12, any one of those times it was there in mathematics. Now, from here, what I would try to do is something like this. The first and foremost information which I have is that there are two classes. There is one class which corresponds to cow. There is another class which corresponds to car, which is essentially formally mentioned using two different labels which are called as omega 0 and omega 1. So this capital omega denotes a set which can have two different manifestations. So essentially this variable can have a value either omega 0 or omega 1. So these are essentially two primal constructs which can be the value over there. Don't get into this too much of jargon. So omega 0 is some sort of an alphabet like A or B or C or D or anything, whatever you think. So omega 0 is a container which can be a cow, and omega 1 is what we refer as car. So the reason of doing omega 0, omega 1 is that you will not always have cow and car, you can have something else. So if you're writing a code, it becomes too complicated. If your problem changes from a cow car to a idiot versus a non-idiot to something like a male versus female versus third gender. then you will have to keep on changing, and you cannot keep on changing all variables. So we start writing them as omega0 and omega1. That's the basic formal logic why we do it. Now from there, you would get down to something which I called as a histogram, essentially, which is a count of how many cars and how many cows are there. Now if you look into this image, you would see that there are 4 cars and there are 7 cows. So there is 1, 2, 3, 4, 5, 6 and 7. There are 7 cows and 4 cars over here. So that's this histogram which I'm getting. Now from this histogram, I can get down a probability. So the probability is something like this. So what this probability shows me is what is the probability of a certain class to be present over there. Okay, and in fact, this thing is exactly this prior probability over here. So this is the first part which we have solved. So what is the probability that there is a car? What is the probability that there is a cow? So the probability that there can be a cow is 7 by 11. The probability that there can be a car is 4 by 11. Great, done. We are happy. Everybody is happy. Now from here, we go down to another thing which is like if I have this mod of omega naught that signifies in formal mathematics something called as cardinality of a certain set. So cardinality of a set basically means that if omega naught is the set of all cows, cardinality is the total number of cows which are present in that set. So the total number of cows is 7, total number of cars which I have is 4, and that's what works out over here. Great. Now from here, we would like to get into the next part. Okay. So the next part is trying to get down this thing which is called as likelihood. So what I have done over here is, if you note it down, let me replay the animation. So now I am trying to break this x1 into some number of small bins or certain ranges over here. So between this is one range. So anything which is present over here versus present over here, everything is going to be in that first ribbon itself. So similarly, I break it down into multiple ribbons. So you can call them as ribbons, beans, bands, whatsoever. There are multiple names. Typically, bins is a very commonly used term over there. Similarly, I can break the other axis, which is x2, into such kind of bins. Now, what this means is that a healthy person is somebody who is, say, between 5 feet 5 inches to 6 feet in height and has a weight in the range of 50 kg to 80 kg. So you have these two constants. One is on height, another is on weight, which you have put down over here. And so similarly, here also we have these kind of two constants which we do. So we have these kind of boxes which come down. Now each of these boxes will have a range, and that is what is called as a bin. A bin is something like a bucket, paper bin, waste bin. That's the place from where you get. So a bucket can have multiple items over here. So whatever it holds over here is what is considered as being contained inside the bin. Okay. Now these bins are something which we will use for finding out the likelihood. So first and foremost is I find out what is the total constituent in this bin. Now see, there are certain bins like this bin and this bin where there is nothing present. There is this bin on which the car can be distributed, but generally this car is present over here. That's why we took the car to be present over here. Okay. So somebody is actually, let me resume. Okay, so now my presentation should have resumed over here. So now that is the whole concept of what goes on with the bin. Now what I have over here is that I have just noted the count over here. Now similarly, I can get down something called as a probability over here. So the probability of getting an object in any of these places is essentially this. So there is a 1 by 11 probability of getting an object over here. There is a 1 by 11 probability of getting an object over here. There is a 0 probability of getting an object over here, 0 over here, 0 over here. Like this, it keeps on going over here also 0. So now the essential point of doing this is that if you look over here, there are some places where you will never have any object. Okay. And in fact, this is what is giving rise to this evidence over here. So you would see that this evidence, which is P of X, is what we are able to get down from here. So you have your histogram. From your histogram, you find out your probability. And this is as simple as whatever equations you are trying to solve out in your class 10, class 11, 12 level mathematics with those games of rolling of a die or sorting of a card or playing of cards and all of this, or rolling of a die, tossing of a coin kind of problems. We are trying to do the same thing over here, nothing beyond it. Now, beyond that, if you really look into it, then you will find out another place, which is to get down what is this likelihood. Then this likelihood becomes a conditional. So what it says is that what is the probability that I have a certain cow present with a given measurement. Okay. So what that would mean is that now I need to look into this particular point with only these cows and not with the cars, or the other way around, and get down these kind of a histogram, and from where I will be getting down this kind of a probability, which is essentially my likelihood, which comes from. Now from there I am able to get down similarly for my cars, and now I have all my data. Now look into it. I got down in the first attempt what was my prior probability, then I tried to calculate what is my evidence. Now I had to calculate my likelihood for both the classes, so I have done that for the cow class, for the car class, and now I am standing over here with all of these data. Now that I have this data given over here, if I ask you this question, that can you find it out, say can you find out something else, but there is also something interesting to note, which is your evidence which you have found out using all of this can actually also be solved using this kind of a shortcut rule, which is totally valid, which is you solve only for the likelihood and probability, and then if you take the summation of all of this over all the classes which are present over there, then you would get down your evidence as well. Now from there I ask you this question, that given this location where I place a cross mark, what is the chance of finding a certain either a cow or a car? Now on this picture you are able to look into this one, but for the computer what is going to be over there is you will have these probabilities or these data which is fed down over here. Your code has to actually find out and say whether there will be a cow or a car over there. It will look into certain new measurements which came down, and based on that, so the measurement which came down is something which is based on this particular bin location over here, which is marked in cross. And now you have asked your computer the question that can you look into this particular point which is a cross and tell me whether this is a cow or a car. So what it is going to do is essentially it will start with solving this posterior probability for the cow class and for the car class. So omega 0 was essentially for cow, omega 1 is essentially for car. Now it will solve this equation, for which it will need to take in these values. And these values, if you recall, these values were what were in the previous slides. We had calculated them. So we took all of these values for whatever is present in this particular location. We feed it into this equation, then we get a posterior probability. And you would see that the posterior probability of there being a car is equal to 1, which would essentially mean that whatever you measure over here is definitely going to be a car. Great. Now the question is, if I give you this particular region over here, which is marked in cross, what do you do? See, there is a big problem which comes from, because over here, no object was ever measured. So the evidence is going to be 0. Similarly, the likelihood is also 0 for both of them, because there wasn't essentially any particular object which was present over there. Now that brings you to a dilemma, because you will end up having posterior probability in a 0 by 0 form for both of them. And a 0 by 0 form is undefined. If you had something divided by 0, you can say that it is a value which is very high tending towards infinity. But if you divide 0 by 0, that's an undefined form, because you essentially don't know. Like nothing divided by nothing cannot be something. Nothing divided by nothing is unknown. We don't even know. We cannot even say 0 divided by 0 is 0. So this comes down as one of the problems. So how many of you ever tried writing a program in order to divide 0 by 0? Let's ask. I believe you guys have done some courses in programming. So there are a lot of students, there are faculties and everybody. And I'm quite totally shameless to ask faculty members as well the same question, that if you're writing a computer program and I ask you this very simple thing, that write a computer program to divide 0 by 0, a C program, Python program, Java program, whatsoever. What do you get on the resultant output over there? What does it show you? Float A is equal to 0, B is equal to 0, comma C. And you write down C is equal to A divided by B, A slash B. So what does it show you?
It is logical error. Logical error.
Logical error, okay. What more? will it always throw a logical error? Have you actually written that ever and seen what the compiler throws out?
Sir, actually, a compiler dividing by 0 is not possible. So for this reason, I have told you that it is logical 0.
So how will a compiler know that this was a logical error? See, we as humans
Actually-
that we don't put a condition which is divide by 0, but say that somebody did not do and they put a divide by 0. Or there was some variable, random variable coming from different places, and then there was a divide by 0. So how will a compiler know? Compiler, interpreter, just-in-time execution, anything, whatever mode of execution of programs you are using, how will that know?
Sir, something, some audience has told that a divide by 0 error, it will throw an exception.
Yes, it throws out something which is called as a divide by 0 exception, and that happens only on Intel computers. Never try writing this program and compiling it on a Raspberry Pi which goes with an ARM computer. It will not throw out, it will throw some random values over there. It will throw an exception, and then this exception is a very special property of Intel processors, which is called as interrupt 4, INT4. So what INT4 essentially is, it's a software driven interrupt which gets generated only when a div instruction, which is on the basically AVX instruction set, the div instruction is called, whereby the denominator of the divider is 0. It actually does all of these kind of preemptive checks before it employs it. So that's typically what you get done. The reason is, if you don't do it, then the divider circuit is a iterative divider with a Taylor series expansion over there. It will keep on going forever long. So if this exception was not done, then you can write a program and make it divide by 0 that is good enough to hang your computer for life. So these are those interesting things which happen at points of time. So here it's a 0 by 0 error, but my question is that how will I solve? Can I still solve it? Anything? Do you think that we can still solve even if I don't have a value over here? What is the audience telling?
Sir, till now they have not given any responses.
So everybody is confused over here. Okay, so this is the time when I will introduce exception handling. That's the question. How will I do this exception handling? So for that exception handling, we are going to make use of this particular term called as distribution, and that's of real immense use over here. So you might have heard of and used at some point of time something called as a normal distribution, Gaussian distribution. Some people are more fancier and they would say Poisson distribution, binomial distribution, and all of these distributions. So what is audience telling you on this one? And then people on the chat as well. Distribution. Have you heard about normal distribution, Gaussian distribution, Poisson, binomial?
Sir, Borun Kumar Pal is saying that it is zero division error or exception handling.
Yes, so my question was like, it's exception handling, but we will do this exception handling by something. So the point is, you can say that we will handle an exception, but what do we do? Because I still want to get a value over here. It does not, you cannot say that this is undefined. So one thing would be, you say that question mark is undefined. I don't know, so I will not give you an answer. But a computer does not say that. It is a very faithful servant. It will always give you an answer. So the question is that it has to stick with always giving you an answer. What will it do? And for that, we will get into this whole concept of distribution. And so the next question which I'm asking is, have you heard of these terms called as normal distribution or Gaussian distribution?
Yes, sir. Already I have read probability in probability.
So this is the time when we will make use of distributions over here. And that's the fun part of why we had studied distributions at some point of time. So the whole idea is we'll make use of something which is called as a multivariate normal distribution or a multivariate Gaussian distribution. So typically in your Gaussian distribution, what you had is that there was a probability density function which was given like this, phi of x, and that was oh, this square root is wrongly written for some reason. I don't know. The square root should have been over on top of this one, not this e power of something. That will be outside the square root anyways. So essentially, this e power of half x minus mu times sigma. So this is what you have typically studied in terms of one single variable where your sigma is called as the variance. Now this capital sigma over here is what we call as the covariance. So covariance means that if there are multiple variables, then what is the variance between each of these variables? And you can actually Wikipedia or look something and read about it. The whole concept of this is that using the data which we had available, if we feed into this set of equations and solvers, we'll still be getting down some value of this probability P at this particular location. So now by solving this, what I'm going to get down, so I'm not getting into how to solve that. That's a separate part of computational statistics. Not within the scope of this one. So if we solve it out, what we will end up getting is a very interesting thing. I would get down something where my likelihood, which is over here, this likelihood is going to be looking like 6 by 11 and 1 by 14. 6 by 14 and 1 by 14. Nothing similar to in the earlier case. And now if I feed it back into these solvers, I would get down that probability of getting a car is something like 42 by 46. Probability of getting a cow is something like 4 by 46. Now, if I go by the Bayes rule and do that argmax, then it will definitely say that this is the region where you will get a car with most likely. But then it's not 1. In the earlier case, over here when we were doing it, it was 1, but here it is not exactly 1. This is somewhat closer to that. So this is essentially something which comes down from what we call as estimation theory. So we are estimating based on using some of our well-known understanding about probability and statistics. So are we good till here? Are we clear till here? And then that question, how we measure performance is still there. We haven't yet come down to the measuring performance. Any questions? Anything?
Yes, sir. Totally, we have understood the band math.
Okay, great. So now that we have understood the math, now is a time of a quiz. Do you know this person?
No, sir.
The question is still open. Let's see. Let's see how many different tricks you can apply. You can even try to do a Google image search and try to see. If you're on a computer, you can take a print screen of this one, then crop that image, put it on Google image search and try to find out who this person is. If you're on your phone, you can take a screenshot of this one, then do a Google image search and try to find out who this person is. No, that's not my photo. He has a lot of hair. I have this.
Sir, till now, our audience has not comment right now.
Okay. So let me do the first line of unveiling. So does this name sound familiar to anybody? And don't come and tell that this is Goopy guy. He is not Goopy guy. So does this name sound familiar to anybody?
Sir, Habib Sheikh is saying that yes, sir.
Yes. Okay. So how does it sound familiar to him? Yes, we have one answer on the chat. So he is the founder of your university. But there are like a lot of interesting facts about it. Okay. So that's actually one of the crux answers you got it. So now he's not just the founder of the university. In fact, this whole contribution about this Pearson product moment correlation is something which is what we call as the foundational base of modern concepts on statistical machine learning. And in fact, that whole understanding of what I went back into the previous one and said that we will use a multivariate normal distribution and use it to come down to an understanding of likelihood is based on a particular theory which this particular person had proven when he was doing his PhD around in late 1940s. And that was in this whole area of Pearson product moment correlation. So you might have heard of a term called as Pearson's correlation coefficient for finding out what is the correlation and covariance between independent variables over there. So he was trying to do it when you don't have a particular independence criteria. So variables may be partially dependent on each other as well. And still, can you find out what is the dependence, what is the amount of correlation between them? So that was his primary contribution, and that today is actually a very foundational basis, and that's the thing on which almost 90% of modern machine learning works on. So you can pretty much say that this guy is the one who gave the foundational mathematics to this whole world of machine learning. Otherwise, nobody would have been there. So what we are doing, we wouldn't have done, pretty much. Something interesting is he is actually from the district, and he is pretty close by from the place where you guys are located. So does anybody know about this particular village? Any of these names other than say Cambridge University, no, IIT Kharagpur, ISI Kolkata, and Calcutta University, do the other names sound familiar to you? Okay, does this place called as Hedia sound familiar to you?
Yes, sir. It is Purva Mendipur.
Yes, and how close is Hedia to your place?
I think.
Yes, it is Purva Mendipur.
Actually, 30 kilometers.
I think it should be more than 30 kilometers. Hedia would be about how much? Yeah, Hedia would be about 30 kilometers, yes. So from my place, from Kharagpur, Hedia would be about roughly 80. I know that Lokhi village is about 80 kilometers from Kharagpur. Hedia is roughly about 35 kilometers from Debra. Gaurav says around 90 kilometers. So we'll have to find it out. It depends on which road you are taking and traveling down. So he was actually born over there, and then he studied, and then it was a cumulative through, and then he went for his PhD at Cambridge, and that's where he did all of this, and then he came back to India, and then he was working at ISI and for about 6 months or something, and then he joined the Department of Mathematics at IIT Kharagpur, where he retired as the head of the department in mathematics. And in fact, he's very well known. He's one of those very few people, mathematicians in India, who are members of the Royal Society itself. And he was a direct member at a much younger age. And interestingly, if you look into it, he started working on the concept of Vidyasagar University when he was almost 35 years of age, starting at Kharagpur. And that was through some funds he had from NCERT in order to really look into how do you revive the educational scenario in Bengal. And this is post-independent Bengal. There is a lot of famine, Bengal famine, and migration, the whole issue with Bangladesh going on, the whole liberation army and everything. It's a chaos at that particular point of time. And this guy was really thinking about it. And then that whole thing of the bunch of 7, it was a 6-volume report which he submitted to NCERT, that essentially laid the foundation of NCERT coming back and telling that why don't you put a proposal for establishing a very radical thought process university for the first time in India. And that's how it got. In fact, There are certain programs which Vidyasagar University started, which were for the first time in India. There was no university in India which had it. So it was anthropology, it was on sociology, it was on library sciences. Nobody in India had ever heard of something called as library sciences at that particular point of time. So he was the one who started that, and one of the primary things was that he wanted to have a lot of job-oriented courses. And in fact, the reason why we have a lot of programs on things like BCA and MCA or lab technologies in under Vidyasagar University in a lot of colleges in this whole district is the reason why it is on the foundational charter, and that was not possible if this person in the 1980s wouldn't have written down the charter of the university himself. So this is that wonderful journey, and to me it's a bit interesting because it culminates to my professional life, to my social thinking of how the same person actually got it back and forth over here. Great. So that was a bit of off track for a lot of people. Now we will again get back on track and get you into all of this. And that brings us to something which is called as what we know as uncertainty of decisions. And in fact, this is also based on something where I will take down some contributions of Fisher. I will take down some contributions of Guyan in order to explain you these concepts, though they are much there. So there is a particular thing which is called as information. So how many of you might have heard of a particular term called as information theory? Not information technology, information theory. Okay, let me make it simpler. Information theory is something which says that how many bits would you require to store a certain data in digital domain. Some data which is available in the real analog world, how many bits would you need to store it in the digital domain? That is what is called as information theory. Now it relies on certain very simple terms, which is one is what is called as that if an event is guaranteed, then it does not have any information, which is sun rises on the east, does not have any information associated with it because it will always happen. It's definite. It's a constant process. A likely event is something which will have a low information, which is it will rain today. So it's monsoon. It can pretty much rain today. It's rainy season. It does not have any information over here. But if I say that it will snow today, Mednapur never gets snow. So if I say that it will snow today at your college, that is a very less likely event over there. And that itself has something which is what is called as a very high information. Now that went down together by a person who was known as Shannon. So Shannon was a mathematician from MIT who did come up with this whole interesting point that he used these kind of concepts, mathematical frameworks, in order to define information associated with certain event. So now I will get back to why I was speaking about information over here and how is that interesting. If you look into this whole aspect over here, this is what we had solved from our probability side of it. Okay, you got down your histograms, your probability, you had your likelihood, your prior probability, your evidences, everything over here, and then you have to find your posterior probability. Now, without looking into the posterior probability, if I look into the other side of all of this ball game over here, I would like to look into what is the information. Now see, first and foremost, I have this prior probability. What it says is that what is the probability that there can be a car or there can be a cow in this whole experiment. From there, I find out what is my information associated with the car class and with the cow class. And from there, I get down something which is called as entropy, or what is the total amount of uncertainty in this whole system. Now, entropy again comes down from something like those gas equations which you had in physical chemistry, which was essentially trying to find out what is the total amount of uncertainty. And entropy is also related with temperature of a particular body. So I'm doing a lot of physical chemistry and statistical mechanics over here, but then information actually comes down from all of those concepts itself. So this is what you would get down over there. Now, what is an implication? Why was I really looking into this one? Is sort of interesting. Now, if you look over here, you see that this is a place where you can actually find a lot of cows. So there is pretty much a low level information over here. This is a place where it's unlikely to have a cow or unlikely to have a car, unlikely to have anything. And that's where your information is very high. So as I said, a very less likely event is something which is associated with a very high information. So this is where the information is high. And in fact, these are also some things which are called as anomaly. So an anomaly is a thing which does not generally occur, but has randomly, suddenly occurred. But whenever it occurs, it becomes very critical. Say the COVID situation. The COVID has a very high information, and that's the reason why you would say that everybody is speaking about COVID. Nobody is speaking about cancer. Nobody is speaking about AIDS. Nobody is speaking about influenza and flu. More people in India die because of tuberculosis than the total number of people who have died till now because of COVID. So that's the interesting point over here, that the information is very high when your event is very less likely over there. So this is something interesting. Now you can see another thing, that your information is infinity, but your entropy does not end up tending towards infinity. And that's the reason. The reason for that is because you have this P of X, which is essentially probability over here. Now what will happen over here is the probability that a certain evidence exists over here is 0. And that is multiplied by a value which is tending towards infinity, but is not exactly infinity. So now if I multiply a very high value with 0, that will end up becoming 0. And that's the reason why you will have all of these high information zones not contributing anything to entropy, because the likelihood that they will happen is so low that this will not change the overall entropy of the system over here. So that's something interesting which happened over here. Now from here, what you can actually do is that what we need to find is a whole system which has pretty much a very uniformly distributed entropy. In fact, you can actually tell me what is the limit of entropy. So if I give you something, that if there are 2 classes, so what can be the maximum entropy for a 2-class system? So the maximum entropy for a 2-class system is going to be, I think, something like 1. And no, it's log of 2 essentially. So the whole thing, why we will get down is, you will get it maximum only when both of the classes are equiprobable. If one of the classes is less probable than the other, then you will see an entropy which will come lower than that in maximum entropy. And this is the universal rule. In fact, you can do the whole chain rule of finding out maxima, and then over this whole functional solve it out, and you will see that for a system which has n number of variables which are probable, if the probability of each variable is 1 by n, only then you will get the maximum entropy over there. And a maximum entropy system is something on which we can make the best condition of a decision. So if you want to make data-driven decision, you also need to ensure that you have the highest entropy present in the system of that data. Otherwise, this will not work. So that's from where you can also end up solving for all of these other classes. And that will bring me to this interesting chunk of a word cloud, where you will see a lot of terms. Now these terms which you see over here, they are a bunch of things which have been over a period of something like 1980s till now been used to represent what we called as today as deep learning. And this was how it started. So initially it was neural networks. We started with something called as neocognition. From there we went on to belief networks. From there we came down like this, and then eventually it was on to deep learning, and then what we are going to look into today. Now let's do a quick recall over here. One is, we had this kind of a decision boundary which we were trying to solve out. So we wanted to get this particular equation, and you get down what is called as a decision boundary. Now there is a whole bunch of challenges associated with this particular kind of a decision boundary. One is that if you have a lot of samples, it becomes very easy to construct the decision boundary. So this becomes something like this. Okay. Now, if I don't have so many samples, one possibility of a decision boundary is something like this. Another possibility of a decision boundary is something like this. Now look into the challenge over here. When I go from this one to this one, the order of my equation change. Here I have a straight line. A straight line can be represented as y is equal to mx plus c, where I have just 2 variables which are independent variables, m and c, which need to be found out. And these are what are also called as degrees of freedom, or they are also called as say weights of an equation or unknown parameters within a neural network, or whatsoever you want to call. But it's essentially my 2 degree of freedom system which I have over here when I have a straight line. But if I have this kind of a thing, you would see that there are 2 points of inflection, 1 point and another point. This means that this line essentially is something which represents a cubic equation, order 3 system. And order 3 system will have something in the order of about 16 variables or 16 degrees of freedom. So it becomes very complicated to track it down. It becomes even more complicated when you have scarce examples, which is very less number of samples. Because now, if I want to fit a straight line, this can be one straight line, this can be another straight line, this can be another straight line, this can be another straight line, And all of those straight lines will be equally likely to give you a right answer because they are able to discriminate between whatever is present on the left hand side and right hand side. So these balls are something which belongs to one class and the crosses are what belongs to another class, and the reason I do it is just for notational simplicity, not using those icons of cars and cows anymore over here. Now comes the point that if I have this kind of a system, then let's look into what is the challenge. So if I have this kind of an equation, which will be called as cubic, now this will become a cubic equation because this likelihood over here is a cubic function itself. It can be quadratic, it can be linear. So from a systems equation point of view, whatever is the order of polynomial of this likelihood, if that is a variable, is the same as the order of polynomial of this evidence, because evidence was really summation over this term over here. So that will become the order of polynomial of my posterior probability as well. So essentially, in order to guide the decision boundary, whatever is the order of polynomial of the decision boundary, if that is cubic, then I would need that my likelihood also follows a cubic, and because that comes from an equation, so that equation needs to be a cubic or a quadratic equation, as is the case, which I need to fit down this one properly. So now, if we come to this particular case of really less amount of data where you can fit down only one single equation, you would see that M and C being the variables, they also get challenged because you can have a lot of combinations of these M and C coming down. So now there are two problems over here. One is what is the order of the system, and then or the degrees of freedom, and then the next question is what will be the values of these free variables over here in my complex system which I'm seeing over here. Now that's where we have come a long way till now. So in the earlier days, and this is somewhere in 1960s, what we used to do is what is called as rule-based AI. So you would take an input, you would have a set of rules which are handcrafted. So you set a decision over here. So something similar to air conditioning. So if you set your temperature of an air conditioner as 25 degrees centigrade, then it says if the temperature goes below 23 degrees centigrade, shut off the AC. If the temperature goes above 27 degrees centigrade, then switch on the AC. This is what it keeps on doing. So that's called as a handcrafted rule. You look into one single variable, which is your temperature. You get it from a temperature sensor, and you are going to get your output, which is switching on or off of your AC. From there, we came down to a whole area, which is called as learned decision. And this is where what we were doing over here. So you can have a bunch of features or observations, and you know in some of these cases where it belonged to, but you want to find out what was this decision boundary. And that was what was learned over here. So this is what is within the purview of classical ML. And I did see into the lecture topics and speakers over here, they would be speaking on different aspects of this kind of learned decisions, which will be taking place. From there, we get into what we used to call as representation learning, and is a precursor of deep learning, where the idea was that you have a set of learned features as well. So from input, you derive a set of features, from there you derive a set of decision, and then you come down to this output. And from there, today we stand in this whole era of where you can learn subsequent level of abstract features, and you can do it across depth of things. So it's a multi-hierarchy scenario which comes down, and that's what we call as deep learning. Now, if you look into this whole scenario over here, then it can be divided into certain number of objectives, which is very simple for any machine learning task. One is you need to understand what is the complexity associated with the data. So if there is less amount of data, then the problem is more complex. So always focus on getting more amount of data. That is really needed. Plus, your data should have a very high entropy. That's also one of the conditions, because then it will ensure that it is very uniformly distributed. The next problem which you need to look into is what is called as the model selection, or where you find out what is the degrees of freedom which you need to look into. So the linear is the most easier to solve, and cubic and higher order polynomials are much more complex to solve. The last one is what we call as the control plane of the problem, and that's where the question on how is performance measured comes down to play. So what you can do is you can either measure performance by using simple terms like maximum likelihood estimation, or go down to even a bit more complex thing like a mean square error. But then today we are in an era when instead of mean square error, we use of some terms which are called as perception loss, which is how close is something to the other. So in fact, the first slide which I was showing you about the image of one being an actual image coming from an ultrasound machine, another is what a computer simulated out. The whole way how we made a computer understand that you are able to do something which is very close and very accurate to what will happen in a real system is by using this kind of a term which is called as a perception loss. So now, I will not be getting much into these. There are different ways of actually addressing these problems. Some of these trivial ways are what we call as data augmentation, which is you can have a data which looks like this. You apply these kind of data augmentation techniques, which are rotate, flip, or do some transformations on the data. You can bring it down to this kind of a high entropy scenario. But then don't try doing something on these kind of objects like cows, because a flip up down on a cow is very invalid. If you look into a model selection plane of it, then that's where deep learning really comes into play. Because if you look into this kind of a problem where, say, your features are aligned like this, you need typically a quadratic system to be solved. And for a quadratic, the degrees of freedom is 6. So you have like ax square plus by square plus ax plus by plus cx plus dy plus e x square y plus f xy square plus something. So you keep on adding of all of these terms over there. So that makes it really complex over there, and it keeps on going. So for a quadratic, you will have an order 6 or a degree of freedom of order 6. Somebody has shared the screen.
Hello.
And from there, the way you can do is what we do with going with the deep learning thing is you come down with one level of an abstraction which can transform into this kind of a feature where now your whole boundary can become just a simple straight line separation margin. So from there, we enter into this whole realm of perception losses, where the idea was something like, if I want to create an image, I sketch something and I want to get a realistic image, then you would see that your mean square error is never going to be quite good in telling that it looks like a realistic image. Whereas your perception loss with a realistic image is what is going to be low. So how we model all of this is a real interesting problem. And there's a whole area of work which is called as generative adversarial models or adversarial learning in general, which helps us understand how we can really go around with solving all of this. So this is where we are today, where deep learning forms down a very small subset within the whole area, which is called as representation learning. That itself is a subset within machine learning, is itself a subset within the whole bigger field of artificial intelligence. And then that's where the whole world is going down today. So if you want to look more into them, these are some of the standard reference books which I would suggest you can have a look into for understanding more and more about it. These are some of the journals and conferences which most of us on the community follow, and it would really be nice to look into them. You can Google up my name as well. You would be ending up getting a lot of lectures on YouTube as well as on my standard lecture recordings from the classroom on deep learning as well. If you want to do a much deeper understanding through a standard 40-hour classroom course, then you can do all of those. And beyond it, you can also try out NPTEL, which is really good to get down more. So this semester, I'm actually offering a whole 3 credit, a complete 3 months course on deep learning for visual computing. So that's another place which you can, I'm not sure whether the enrollments are still open, but you can try it out on that one. And finally, on what I come to an end is that is something which we are building up following on the transformation purpose of what I showed with Professor Gayan. So this is a national mission project which we initiated over here at Kharagpur along with a lot of partners from across the world. And the idea is that we are building up not an academic university, not a department or something. This is actually an actual business company. And this is in the area of AI and machine learning. And it's a full company which works as a corporate sector itself. And we would be shortly announcing taking in a lot of people. So people who are interested to look into a career in machine learning and AI, you are welcome to apply to them. And then also it would be opening up a lot of upskilling, reskilling programs in the near future. So keep your eyes up on it. A good place to get down more information is to get into the website. And if you have any specific queries on this one, then you can ask me. And in fact, like to the college, to Debra Sohit Khudiram Mohavidyalaya, the point which I have is that sometime in the next 6 months, we are going to open up an interesting program of adopting and helping a lot of colleges in the vicinity to reskill and upskill their programs with AI and machine learning as part of curriculum requirements, whereby We will be providing materials on how to teach it out. We will train educators to do it. We will help you in creating labs, providing you access to data sets, labs, cloud computing, etc. for your students over here in order to really increase the research base. And our philosophy has been that before we reach out to the rest of the world of what we are doing in order to create and have this motive of having Kharagpur as the AI superpower and the focal center for the whole world and let the whole world come and converge over here. The idea was to actually go and upskill the neighboring colleges and programs over here. So with that, I end my talk, and whatever queries you have, you can basically shoot out and let me try to see if I can answer any of them.
Sir, Habib Sheikh has a question.
Yes, please.
Which software is more feasible for practice ML?
If you have a license for MATLAB, then go and do it on MATLAB. It's easier. If you don't have it, then or generally if you want to be professionally ready, then practice on Python. There is a separate library called as scikit-learn, which works out on Python to do all of this, and that would make you industry ready. So you can do it on R, or you can do it using Deka or any of them. The only point is that it's much more useful for researchers, but then this is not something on which an industrial product actually gets built up. So products are built up on scikit-learn and beyond it. So for deep learning, we have separate libraries called as PyTorch, TensorFlow, Caffe, MXNet, on which actual products are built up.
Okay, sir. Thank you for your presentation. Actually, Jodev sir, are you in?
Yeah. Thank you, sir, for your valuable talk. Okay. In our first session, the second speaker, Dr. Rajkumar Saini. Dr. Rajkumar Saini sir is present here.
Yeah,
Yes,
I'm here.
Okay. First, I am briefly introduced you. Actually, Rajkumar Saini is now a postdoctoral research Luleå University of Technology, Sweden. He completed his BTech in Computer Science and Engineering from Vidya College of Engineering, Meerut, and MTech in Computer Science and Engineering from Kamla Nehru Institute of Technology, Uttar Pradesh, and he done his PhD from IIT Roorkee. Okay, sir. Please tell about your today topics.
Thank you for the introduction. Do you hear me all?
Yeah.
Okay, I don't know how to share my screen. If someone can tell me.
Yeah, you can. Yeah, you can.
Is it entire screen? Thank you. Do you see my screen now?
No. Yeah.
yes,
Now,
sir. Yes, sir.
yes, sir. It is now.
Now,
Yeah. Just make it.
Okay, great.
Make it in presentation view. Yeah. Thank you.
Okay. Thank you for the webinar. So I'm presenting sign gesture recognition using 3D kinetic skeleton information. It is more like applied. And so first we cover sign gestures. Sign gestures are to communicate with hearing or speech impaired people, like who cannot talk or who have some difficulty like speaking. So usually you have physical visual sign gestures that usually involve your hands, legs, sometimes facial expressions as well. They are static and dynamic, like you can just show your hand, which is like you do not move your hand or legs, so it's called static. But if you move your hand, that move hand or legs, then it calls dynamic because it the gesture changes with time, the motion changes with time. So and they are also finger spelled. So sometimes you have a gesture for hello, but you spell it with its English. So a particular gesture like cool, so you show COOL to represent cool with hands, and it also depends on region. Same gesture can represent different meanings in different regional sign languages. Usually in India, it follows subject object verb structure. So first you show the gesture regarding the subject, then you show the object, and then you actually tell the verb. So this is the usual structure in India, but in American Sign Language, it is OSV, and even verb is coming first. So it varies with the place to place. So why 3D? If you see the first picture, we cannot say if the machine, it is hard for the machine to recognize whether the first person is behind the second person, but humans can do that. Why we can do that? Because we have learned ourselves like since our childhood, and we have so approximately 86 billion neurons, and this kind of learning is hard to mimic in hardware or software, but it is hard to find the distance between these two guys, or even actually saying that who is taller or who is smaller. And in the second figure, we cannot say that this person is actually mimicking the walking, but it's not actually walking because we do not know how much is the depth from first frame or the frame of reference. So that is why it is hard to analyze the depth in images or in 2D videos, and many gestures have this depth information which plays an important role. So if we have this depth, then it would be good. Otherwise, otherwise it will be difficult to learn from these images or videos. So when we have depth and when we have XY, then we call it 3D simply. And then there's a device called Kinect. Kinect, it gives you human skeleton, usually 20 joints, and each joint is 3D XYZ. Z is actually depth from the distance from the sensor, and this sensor has one RGB camera and depth sensor to actually find the depth, and set of mic, and it's simply you get everything, RGB video and depth video and the voice as well. And with this tilt motor, you can actually rotate this Kinect device, and the axis shows how is it recording the data. And these are the joint names, usually 20 joints in 3D. And this video, oh, it's not playing. I think there's a problem with this video, it's not playing, but it's usually showing that how we record this skeleton information from this Kinect device. Okay, so usually this gesture is a sequence of 3D coordinates x1, y1, z1, x2, y2, z2. So each frame is having 60 values corresponding to 20 joints in 3D. Okay, so in during I was in IIT Roorkee, we collected sign gesture data with the help of Anushruti, which is a school for hearing and speech impaired people. So we collected 30 Indian sign gestures from 10 signers, and we repeated each gesture 9 times with some rotations. So three gestures for frontal view, like I'm standing in front of Kinect, then I rotated a bit, roughly 45 degree, and then I recorded 3 more gestures, and then I rotated myself roughly 90 degree, then this is a side view 2. So in this way, we collected 9 samples for each gesture. So total 2,700 gesture. In second, in the video, in the image, you see some gestures. They are from, it can be single-handed or both-handed. So we are showing the first and the last frame of these some gestures, afternoon, child, and in the B figure, they are two both hand gestures that you use both the hands. And this is the two gesture plotted. First column is frontal view, second column is side view 1, then side view 2. So as you see that if you compare first column with the third column, that you lose xy usually, and you cover this xy motion went to z direction, and yeah. So you are waving head in the frontal view, which is covering mostly x and y plane. But when you rotated yourself to 90 degree, then this motion went to like towards z direction more. So we need some processing with before we actually try to develop some recognition system. So this was the framework. We recorded the data, then we use some affine transformation to fix this rotation and scaling. Then we chose some joints which are like prominent in the data set, and then we extracted some feature and then used HMM, hidden Markov model, for the recognition. And for reference, I have given you video regarding how HMM works. They are in the links. So first what we did, suppose we have these 20 joints. Using these 20 joints, we create a plane using shoulder joints and the spine coordinate. So we created the plane, and we try to rotate it towards z-axis and shift it to the origin. That is how we are like transforming from side view 2 to side view 1, so that they look typically similar. So this is the example. We have this first column, second column, and third column. Basically, first column is your frontal view, side view 1 and side view 2, and then we applied this affine transformation to bring it to the similar to the frontal plane. And this is the transformation. We use rotation and translation. That's how we pre-process the gestures. After that, we collected the features like 3D positions of wrist and palm, and then angular feature, like if we have a 3 points, these in XYZ plane, LMN, then we take 3 points and we create a vector from L to N, and then we get the cosine angles that it makes with the coordinate axis. And then using 3 points, we try to create a circle, and then from this circle we find the center, we find the radius, angle, which is making with this perpendicular bisector of these two vectors, and we are using them as a feature and calling it as a curvature feature. And then the difference of from next frame to the previous frame, we are calling it velocity. It's simply a difference from next frame to the previous frame. And then it totally come up with 68 dimensional feature. So now we have a feature trajectory from XYZ to XYZ, angular feature, curvature feature, and velocity. It covers 68 dimension. Then using those dimension, we use HMM to classify them. It's a supervised classifier. That means you have to give the class labels with the sign gestures. And then we trained it. We trained the HMM with different HMM states and with different Gaussian mixture models. So the first graph is showing you the performance of the sign gesture recognition with different Gaussians. So as you see that at 64 Gaussian, it usually works well. In all the cases, like if we develop single-handed, double-handed, or when we train with combined, so it's mostly good at 64 Gaussians. And the here HMM state is 4. And the next plot shows the Gaussian is 64 and number of states in HMM. So at 4 state and 64 Gaussian, it usually work better in all the cases. And this is the confusion matrix. So you see the blue color is representing the misclassification kind of, and the diagonal is representing the correct classification. So it is good. It's learning well from these features that we have extracted. And so we trained from different views. So the first figure shows you the view from when we trained from the frontal view and show the performance on each view. So when we use feature data, the performance is 86.67, but on the raw data without features, it's 60.67. So features are really discriminating these sign gestures in the same fashion in the side view 1 and side view 2. And the second figure shows if we train with all views, then the performance is higher because it covers almost all the variation in the gestures, and the average performance is 83.77. But here is to note that we used a protocol like leave one user out in these experiments. Suppose we had 10 users, so we trained the system with 9 users and then tested the 10th, and then we changed these 9 users in the next set of experiments and tested the last one, so that we get the independent of user scenario. So this is important. So sometimes what happen, if you train with all users, then it works on your training data, but when you test it, it doesn't work really well. So you can say that it is overfitting, or somehow it is learning user, not the gestures. So it is good if we use user independent approach. And then in these results, we are showing we are comparing the user dependent. We also conducted user dependent experiments where all the data from all users were in training and in testing. So as you see, if we add all the information from all the users, so results improve, but I don't suggest that you use this, but it's just for the comparison, just showing the results. So then we use this handcrafted features in this work, but what if we use deep learning? And the reason is we might not know all the good features that can really discriminate the gestures. It's good if it is learned by the model itself. So deep models can discriminate better just with raw data, but you have to give the sufficient data and proper network structure. So this graph is, yeah. It's gone. Do you see now? Okay, I don't know why it happened. Okay, so what if we use just raw data and use deep learning, and then we can see if we learn better or not. But you have to have some good amount of data, and you have to design good structure for that. Okay, so on the same data, what we did, we normalized it in the network, and then we trained some GRU, gated recurrent unit network, and then we checked how does it work well or not. So now we just feed 60 dimension data, which is just raw data, 20 joints for each frame, and it's a sequence. And then we normalize it with 0 center. We shifted the mean to the center. And then we had a GR unit, which is the input size is 60, and we are having 120 hidden units. Then it's a fully connected layer, which is the input size is 120 and output is 30 because there are 30 gestures. And then softmax, and then we have a multi-class cross entropy to minimize this loss through this network. And these are the hyperparameters, like number of epochs were 50, minimum batch size was 30, optimizer was Adam, and initial learning rate and dropout factor, these are here. And after this, we trained it from frontal view, from mid view, and from side view and mixed view. And if we see the first table, when we trained with front view, the performance is 70.78, but when it was HMM, it was just 60. So we can say that deep learning is learning better feature from the raw data. And in the mixed view also, it is improving. So it's learning better feature as compared to HMM base. So this was the 60.67 was this paper. They reported 60.67 from raw data, and we use the same exact experiment protocol, like leave one user out and conducted different models, like bidirectional LSTM is with 60 hidden units, it does not work well. GRU with 60 hidden units, it's 60.11, and bidirectional LSTM with 120 hidden units is 55.89, but GRU with 120 hidden units, it's 70.78. So it's improving from raw data, but one thing we can note here, if we feed, either we have to feed good amount of data, or we can use feature representation as well. If we use those features in GRU, I think it will improve more, but it might take more time. And okay, so yeah, as I said, deep models can learn from raw signature, but we can feed features as well. So it might improve, but it was not done here. And the problem with the skeleton information, you do not have facial expression. So those gestures which cover facial expression, they will not be classified correctly. So we need some other models, like if we integrate facial image or video based model as well, and we combine with the skeleton information, then we might get good performance, but it usually computationally expensive. So this is something we are thinking to do now. And I think, yeah. And one more thing is, which is important, it is training, validation, and testing split. So you have to be very careful. Usually what people do, they split a signal. Let us say we are developing some sort of brain signal classification, and they have some recording, and then they split in, let us say, three partitions. And then as you see, these partitions are sharing 50% or some percentage of the previous signal, the previous segment. So now after splitting, you have created 3 times more sample, but when you train it, you split it randomly. So you are no longer independent of user or this split, because 50%, if we choose second one, the second as a test, so it is already covering the first second half of the first. So it is the same information is somehow present in the sample, so it's no more independent of, let us say, user or signal. So you have to have like proper unseen test data, otherwise it will cost you, I mean, it will not be a good model, and it might not work in real time. And yeah, so these are the references that we use in here. And now we can discuss more. I need your inputs, like how can we develop good sign gesture models. And now I'm open for the questions. Hello.
Sir, till now we have not get any question from audience.
Okay, so no questions. So I just can tell you that be careful with the train validation and test split. Try to develop user independent, session independent, try to incorporate that, and that would be a good model. Okay. If no questions are there, then I will stop sharing.
If participants, have you any question to sir? I am asking to all participants any questions. Any questions? Sir, Habib Sheikh has a question. Why not cover facial expression? Kindly clarify.
Yeah, as I told you, some gestures involve facial expression, so it was just we did not use it because we wanted to develop the gesture which do not cover facial expression. So that's why we use this Kinect. But yes, we have the work that also covers facial expression, and that is already available, and I will share it as well. But yes, it is important to cover this depth stream and Kinect skeleton and facial RGB video as well. Then it will be a complete sign gesture recognition system. Otherwise, you will not be able to cover all the sign gestures.
Okay, sir. Thank you. Thank you for your informative speech. Radev sir, are you in?
Yeah. So thank you very much for your valuable speech.
Thank you.
Okay.
Should I stop sharing? I don't know how.
Yeah,
I think
yeah.
yes.
That's on. That's on. Yeah.
Thank you.
Yeah. Thank you, sir.
Okay, sir. We are.
So now we'll give a lunch break.
Yes, sir. Actually, this is our technical. We have just completed our technical session one on first day. Now we are stopping our program in.
I lost your voice.
Hello.
Yeah. So when are we joining back? In 1 hour or 2 hour?
Sir, our next session will start from sir on 20. Sir, our next session will start from 1:20.
Okay. Okay. Thank you.
All participants are requested to rejoin after 1:20 p.m.
Hello. Huh. Good afternoon. Okay. Okay, I'm waiting. No problem.
Gaurav sir, are you there?
Yes, sir.
Okay.
Please tell me when it is going to live.
Rosanto sir. Somu sir, when?
Please let first join. Let first join everyone. Please wait.
Okay. Okay.
Would you please tell me the audience whether they are students or?
Yes, sir.
Actually, ma'am, there are various types of participants are there, but mostly there are students, and we have also got some assistant professor and associate professors, and some research scholars are also in our system. So these are the total audience.
My duration is 1 hour from 1:30 to 2:30. So I think the discussion session is included here. So I am requesting you to interrupt me if I cross my time. I would like to give time more in the discussion. So at least 10 minutes. Okay. So you will tell me, ma'am, only 10 minutes remaining. Okay.
Okay, ma'am.
Rakesh sir, please inform when it is going to live because I am not seeing actually the YouTube platform. So please inform when it is going to live.
Okay, sir. So Somu
Sir,
sir.
YouTube live is going.
Everyone has joined. Means from our side. Shall I start?
Okay, sir. Wait 2 minutes more. Actually, we have written there in our leaflet that 1:30 p.m. starting session. So please wait 2 minutes.
Sure.
Okay, sir, start. Gaurav sir, start your, please. Gaurav sir, are you there? Gaurav sir, are you there?
Hello. Yes, yes, yes.
Okay. Start
Hello,
the session.
everyone. Hello, everyone. Welcome back, all of you, for our next post-lunch technical session. I think we had a cognitive and lucid session in early morning, presented by Dr. Devdut sir and Dr. Rajkumar Saini sir. We are very much thankful to them. Now, before proceeding to the next lecture, let us share a brief view about our department, about the motive of choosing this topic for the webinar. Hello world. We, the concatenated resultant conglomeration of Department of Computer Science and Computer Application, are ecstatic to represent ourselves in a broader premises through the web communication by showcasing our thrive and imagination. As the field of our core motive initialized from system, so there would no better choice than this neotoric aspect and its ensuing incremental state. And who doesn't know about the infinite loop of mind as rational form? Yes, you guessed right. Learning. The only substantial method which is polynomial in every human being. We are hopeful that the gracious presence of all the dignitaries enriching ourselves to conquer the goal without dividing the togetherness of bonding in future. Now, I would like to introduce Professor Dr. Tandrapal Madam from NIT Durgapur. Dr. Tandrapal is an associate professor in the Department of Computer Science and Engineering, National Institute of Technology, Durgapur, India. She received her BSc degree in physics from Calcutta University in 1986. She did her BTech degree in computer science and engineering in 1991 from Calcutta University and ME degree from Jadavpur University in computer science and engineering in 1993. She received her PhD degree in 2010 from Jadavpur University in engineering. Now let me share about her awards and achievements in brief. She received Gold Medal Award for obtaining highest marks in BSc Honours Examination from S.A. Jaipuria College, Calcutta University in 1986. She received Professor A.K. Chaudhary Memorial Award for obtaining highest marks in BTech Part 2 Examination, Computer Science and Engineering, Calcutta University, 1990. She also received Best Paper Award at the first International Conference on Business and Information Management, ICVIM 2012, Durgapur, India, and Best Paper Award at the 7th International Conference on Computational Sciences and Optimization, CSO 2014, Beijing, China, on 2014. She serves as lecturer at North Bengal University, Siliguri, Darjeeling, West Bengal. She has published more than 40 research papers in national and international journals and conferences. Her area of research includes computational intelligence, soft computing, multi-objective genetic algorithms and their applications, fuzzy logic, artificial neural network, pattern recognition, fuzzy logic controllers. So here I would request Madam, please take over the upcoming session with your views and visions on the advances in machine learning.
Thank you very much. Am I audible? Hello.
Yes, ma'am. Yes, ma'am.
Thank you very much for a nice introduction. However, I think you have collected my short CV from somewhere else and it is very old. Now I am professor and working as head in the Department of Computer Science and Engineering in NIT Durgapur, and now my publication is about 70, including journal and conference. However, it is fine. Now, I am really thankful to the organizer for inviting me and giving a chance to share my knowledge, and always any discussion, any talk that will improve or extend my knowledge also. So now I would not waste the time. Let us directly go to the presentation. Actually, machine learning, here I will discuss a very well-known machine learning algorithm, clustering. Actually, my aim is not only to discuss a very well-known algorithm, K-means clustering, but how to we can do clustering using SOM, a neural network self-organizing map. So now I am sharing my PPT. Is it visible? Hello? Hello?
Yes, ma'am.
Yes.
Yeah. So, considering different standards of the participant, actually, I want to give a short introduction of K-means clustering. In this discussion in the webinar, I will not go the detail of any algorithm. Just I would like to provide the idea or the philosophy behind the algorithm, such that the participant, if become interested in future, they can go into the detail of it. Now let us see first what is K-means clustering. What is clustering? Clustering is the grouping of similar objects. For example, here we have considered three types of object. So here we are interested for clustering for three clusters. Okay, and for
Ma'am, I am interrupting you, ma'am.
Okay.
Ma'am, I am interrupting because your PDF is open in app. For this reason, we have not seen anything until now. Please open it in browser. Open it in browser.
What does it mean? I have opened it in my laptop.
Adobe Reader. Adobe Reader.
Oh, it is PPT. So I have to now the animation is there, so I cannot use the PDF. Okay. There is only window, no PPT window actually. Okay, okay, let me try, huh? Okay, okay, I am trying. So you are actually viewing everything in my laptop.
Yeah, yes. Hold that.
Oh, okay. At first, let me open it. Okay, thank you. Thank you for your help. Is it okay now?
Yes, ma'am. Yes, ma'am.
I think it is okay, full screen.
Yes, ma'am.
You will tell me when to start, huh?
Okay, ma'am. Start your session.
next slide. Is it visible? Clustering, the process of grouping a set of
Yes, ma'am.
objects.
Yes, ma'am.
Okay, then
Yes, ma'am. Is it visible?
Yes. Thank you so much for your assistance. So
Okay.
clustering is just grouping of similar objectives, and here we see there are three groups, that is three clusters. Okay, and for simplicity to understand it, actually we have colored by three different colors. So in this case, samples within a cluster should be similar. So all the blue, so here the points or small circles, actually we are considering as object or points. So these are similar, so they are in one group. All the red circles are similar, so they are in another group, and so on. So there are three groups, so three clusters. And clustering is a machine learning algorithm, and it is unsupervised. Unsupervised means there is no teacher. So in this case, when the samples are given, it was not colored. Color means it is labeled. So for clustering is unsupervised and there is no labeling. Actually, we have to label it. That means we have to make the clusters or grouping. Now I will go to show about how K-means algorithm works, and a very well known, however well used clustering, and is being used by many researchers and in many applications. So in K-means clustering, we assume that K is the number of clusters, and actually it is not given. So this is the problem, one of the limitation of K-means clustering, that we don't know K. So we assume a value for K, and that many clusters we prepare. However, there are some solutions that how number of clusters, that is K, can be optimized. I am not going into the detail of that solution or how to find K. Now, what is K-means algorithm? It is a heuristic method that is not always deterministic, and it is iterative. It is learning in many iterations. And there is a goal, which is actually the heuristic, what we want to minimize. That is the objective. K-means is considered as one of the most used clustering algorithm due to its simplicity. Very simple. Its philosophy of working is very simple. It is just like the way we will group given different types of objects, and widely used in many applications. Each cluster is represented by the center of the cluster, and the algorithm converges to stable centroid of cluster. So actually, the clustering algorithm grouping or making the clusters means actually the output is the center of each cluster. So given a set of objects, then we have to do the clustering means actually we will find the centroids of this cluster. So there will be one centroid. The output is actually in this case three centroids or three centers of three clusters. So there is a center or centroid for this cluster, and one for this, and one for this. So initially we randomly initialize the centroid. Actually we learn the centroid through the clustering method. It is an iterative algorithm that tries to partition the dataset into K predefined distinct non-overlapping subgroups. That is, in this case already I have mentioned that K is the number of clusters, and it is not given what is the value of K. So we assume a value of K, maybe 2, maybe 3, maybe 4, and we actually, the clustering will be done assuming that many number of clusters. And in this case, another assumption is here that the clusters are not overlapped. That is, in this case, you see but they are disjoint. All the clusters are disjoint. There is no blue circle in the region of or in the cluster of red circles, which is not always realistic. And that's why just I would like to mention there is so many modifications of k-means clustering for making it suitable for different applications in real scenarios. So always, I think you already know fuzzy C-means algorithm. So fuzzy C-means algorithm is actually the extension of k-means algorithm, where the groups may not be disjoint. That is, there may be overlap. For example, there is a group of singer and there is a group of dancer. In k-means clustering, we always assume that a person who can sing will not dance. But in reality, a person who can sing can also dance. So in fuzzy C-means clustering, it is more realistic than the k-means clustering, but I am not going into the detail of it. Now, it tries in any clustering, we try to minimize the intra-cluster distance and to maximize the inter-cluster distance. That is, here in the figure, there are 3 such clusters, and we always try to more compact for any cluster. For example, the cluster which contains the blue circles, this will be the area should be as much as possible the less. Okay, but the distance between any 2 clusters, that will be as high as possible. It depends, of course, it depends on the distribution of the data set. And the distance between any 2 different clusters, we call it intercluster, and the average distance of it among the objects, here the circles in a particular cluster, is called the intercluster. So for any clustering algorithm, the objective is to minimize the intercluster distance and to maximize the intercluster distance. And in k-means algorithm, there are only 2 steps. What are these? Initialize k random points as cluster center. That is, initially we don't have any knowledge about the distribution of the data set. Data sets means here the objects. Those objects will be grouped or clusters according to their similarity. Similar objects will be in a cluster and dissimilar objects will be in different clusters. So at first we randomly initialize the cluster centers, and of course we assume say k equal to 3. So in that case we randomly take 3 such centers, and it may be from the data point also. For example, say given say 150 data points or objects or elements, then among those 150 randomly we may take 3 such points or elements which we are assuming initially as the cluster center. Assign data points to closest cluster center by measuring with a specific distance metric. Then what we will do, we will take the object one by one and we will check which one is the closest, which center is the closest among 3 centers. Okay, and that data point will belong to that cluster. And then assign the center to the average of the points assigned to it. So at first we assign a point to the cluster, and if it is complete for all the data points, then we consider all the data points belonging to a cluster and take the average of that, and that is actually the centroid of that cluster. So actually in clustering algorithm, once you initialize the centers by this loop, here the steps 1 and 2, actually the centers are being learned. That is, they are moving from the initial center ultimately to the final center. Hello? Hello?
Yes, ma'am. Yes, ma'am.
If actually I am not habituated in the online seminar, so if you have any doubt for any participant, I am requesting, if any doubt, then please you interrupt me. And if I can interact with you, then only I will success in my presentation.
Okay, ma'am. Okay.
Now, for any algorithm, there is some objective. In this case, actually the objective here is to minimize it. That is to minimize the distance between the center of a cluster with all the points belonging to that center. And in this case, actually it is disjoint cluster. So always omega ik equal to 1 for data point xi, it belongs to cluster K. That is, if Wik, which is called belongingness, either it is 1 or it is 0. So if the ith data point, that is xi, belongs to the cluster K1, then omega ik equal to 1. That is omega I1 equal to 1. For other k, it will be 0. I am not going into the detail of mathematics. It is not possible actually to understand it in this short time. So I'm trying again only the philosophy, what we actually try to do by the demonstration. So this is the K-means algorithm. Just what I have told, there are two steps. First is the assignment of data point into a cluster. And once the assignment is done for all the points, then we modify or we change the cluster, or we move the cluster to a new position. That is, the clustering points are being moved from the initial or random position to the final position. So in this case, we are assuming first that say there are k such groups, okay, and so we are choosing k random points as the initial centers, okay, and that we are calling initial centroids. Actually, in clustering, we sometimes use centroid, sometimes medoid. I am not going into the detail of it. A very minor difference between the centroid and medoid. Now we are considering the data point one by one. So in this case, we are considering there are n such data points, and that is xj, j varies from 1 to n. So we will take the data point one by one, say x1, x2, in this way up to xn, and we will check this xj is close to which center. Okay, and if it is closest, for example, in the center here, say I, then xj will be assigned to the cluster ci. Okay, so this is done. This is a loop.
Hello, ma'am.
Yeah.
I guess I have a question.
Yeah.
If there is a data set where there is a cluster, and between the same clusters, other cluster occurs, then the center would be in the middle, but the middle had.
Just a minute. Very important question that I have already mentioned. In K-means algorithm, we assume there is no such overlapped samples. That is, they are disjoint. Okay.
Thank you.
That, and for that, which is not realistic, for every algorithm there are some pros and some cons. In K-means clustering, we assume that there is no overlapped clusters, all are well separated. And in real scenario, actually we can handle, we modify the K-means algorithm, and already there is very well known and well used clustering algorithm, which is fuzzy Siemens algorithm. Okay, so you can go through it. Yeah.
Ma'am, Piyali Kormakar has a question.
Yes.
It is centroid based clustering mechanisms, but can we relate this type of clustering with boundary based classification or boundary based grouping like SVM?
This is also a very good question. There are so many types of clustering. Okay, now I am actually using partition based clustering, and K-means clustering is one of them. Other I am concentrating on this small topic. Okay, so there may be the hierarchical clustering and so many things, and the people are working, many researchers working on the clustering, and they are modifying the clustering algorithm according to their requirement. Okay, And for each algorithm of clustering, there are some advantages, some disadvantages, and we use that one which is suitable for my problem or for my data set. Okay. Hello.
Okay, ma'am.
Right.
Okay, ma'am.
Okay. So in this case, all the data points now we have in the step 2, we know in which cluster, that is corresponding to which center it belongs. And once we know it, then we actually, for each time you will see by the demonstration followed by this slide, that the clusters assigned in a particular the data points which are currently assigned to a particular cluster will be different. Okay, that is the data points now belonging to a particular cluster may be assigned to other cluster. Okay, that will be clear by the demonstration. So now after step 2, you will see there are some clusters that we have I have shown by a particular color. We will take the average of it, and that will be the centroid of that cluster. So each time, once the center is done, then again I will assign the data points, okay, according to their distance from the new clusters. So in this way, once it will converge, that is, the centers will be stable. That is, you then cannot be able to move it. Okay, then we call clustering has been done. Now you see the demonstration. Here, K-means clustering algorithm. You see, this is, you see at first, all the data points I have made it green to show that we don't know which point belongs to which cluster. Okay, that is, they are not level. That is why this is unsupervised. We don't know which point belong to which cluster. Now here you see, just randomly I have selected, in this case we have assumed k is equal to 2. That is the limitation. That is, you have to know what is the value of k. So k equal to 2. So randomly I have chosen the red and blue, this cluster, these points as the initial centers. Okay. Now what will be happen? In step 2, you see all these green colored point, that is, all the data points will be taken one by one, and they will be assigned to that cluster, either corresponding to the red center or blue center. For example, say if I use this data point, right, then if I take the distance from these two centers, then no doubt it will belong to the cluster corresponding to this center. And that's why you see here, okay, and here we have done this for all the data points here. So when all the data points have been considered and we have determined to which center it is, it belongs, then you see we are coloring. That is, all the red points here belong to the cluster corresponding to the center this, and all the data points having of blue color correspond to the center of this. Is it clear, dear participant? Hello.
Yes, ma'am.
So now you see step 2. Here step 2 has been done, complete. Now what will be in step 3? In step 3, we will find the new cluster center. Actually, now if you take the average of these red color points, right, then you will see this is not the initial point. Now it will be changed. And similarly, it will be changed. So currently, this is one center and this is another center for two class. But if I take the average of these red points, then this will change. And if I take the average of this point, then also this will be change. This will change. That will be the new cluster center. And you see, we have done it. And in the previous slide, you see the cluster centers. Okay, these are the cluster center, and after that, after taking the average, these cluster centers have been changed from these two to these two. Is it clear? Now you see, again I will do the step 2. That is, again we will consider all the data points, okay, and according to their distance from the cluster centers, again they will be assigned to one of the clusters. And after this, you see, we here these are the points which belong to this cluster, but now there are changes. That is, some of them belongs to this cluster, but you see this one is left after the change of the cluster center. It belongs to this center. Okay, so we will repeat it and ultimately get the final cluster centers. You see, and ultimately you see we are getting, they are moving to the final points step by step. That is, in each iteration the algorithm learn for a better cluster centers. So finally you see we will get it. So this is the final center for this cluster, and this is the final center for this cluster. So ultimately the clustering algorithm will produce the result which are the centers. These centers actually the output, and we have the data point. So once we compute the distance of any data point from the cluster final cluster center, easily we can determine in which cluster it belongs. So this is actually in short.
Madam,
yeah. Yes.
Madam, Sudipta Banerjee has a question. The points in two cluster region centroid are arbitrary.
Yeah, the centers initially can be arbitrary, or you can take the center from the data points. Actually, you have to know the domain of the data set. Okay, so you take any point from that domain, or you can take randomly any 3 or 2 points. In case of 3 clusters, we will select any 3 points from the data sets. Or in case of 2 clusters, you can take any 2 data points from the data points or data set. Okay, and it shows, you see the initial, right? Yes.
Sudipta Banerjee has also a question.
Okay.
How many times the cluster center can be changed? We can determine that previously.
No. That is the convergence. Okay, for any materialistic data, you don't know how many iterations ultimately it will take. So that is the important, that is called convergence criteria. Okay, so what we see, in each iteration we check the changes, okay, in the centers. Say, for example, say now P is the center. In the next, the center is Q. So we take the difference P minus Q. So when P minus Q is very less, sometimes 0, right? But in reality, sometimes it is not 0, but there is a threshold very less. That is when P is almost equal to Q, then we can assume that the algorithm has converged. So then we will stop it, and then we will get the final cluster center. This is the philosophy of all meta-heuristic algorithms. And for a particular data point, now if, for example, say now it takes, say, 150 iteration, in the next time it may take more than that, less than that. Okay, because it will depend on the selection of the initial cluster. Is it clear, Sudipta? Most probably. Hello? Hello? Am I audible?
Yes, it is clear.
Okay, okay.
Yes,
thank you so much. So you see in this case just how the clusters are being changed from initial center to the final initial position to the final position, that is shown. Okay. Now another thing you see, initially you see in this case all are labeled as green. That is, we don't have any idea about their level, that is in which point they are in which cluster. Okay, but here we have assumed 3 clusters, and ultimately you see 3 clusters have been assigned after learning with 3 different colors. And for the green, the center is green. For the violet, the center is violet. For the orange, the center is violet. Okay, I think you can understand the initial point. I can make it slower actually. Initial point and final point. Any question, please?
Ma'am, Piali Kormakar has also asked a question that clustering dataset, clustering dataset into K cluster, can we do subclustering onto the cluster using the centroid and point positions?
Actually, you see, that's here what we see 3 clusters. Okay, but when a data set is given, you don't have any idea of this, you don't know the distribution. Here is a 2-dimensional data set, that's why I can see, yes, actually 3 clusters is nice for this data set. But when it is multi-dimensional data points, maybe 3-4 dimensional, then it is not possible to see it by plotting it. So in that case, actually you have to assume K. Okay, and there are many such index, right, which is we call clustering index. Using that idea, we can find which K is best for this data set. So the subclass or class in a class, okay, that idea is not suitable for this clustering method. However, if you go for the hierarchical clustering, okay, maybe from top or maybe from bottom, then the subclass idea of subclass is more suitable. However, here also, once 3 cluster you know, then you can consider a particular cluster, and then you can find some other clusters in that cluster. Is it clear? Hello? Is that clear? Okay, thank you. So this is to show just only one cluster. Right here, I have considered only one cluster and one center. So this was, you see, this was the initial position. Now with iteration, the center now is being moved to this position. Okay, and all these are the points corresponding to this cluster. Okay. Hello?
Okay,
now we have got the idea of K-means clustering. May not be in detail, but philosophically we know how the clustering is being done by K-means clustering. Now I will go for the next PPT, next file to show the clustering. Actually, my intention is the similar concept can be used by some a neural network self-organizing map. Okay. Let me go to that PPT. Is it visible, self-organizing map?
Ma'am, I have a question.
Just a minute. Let me slideshow. Yeah. Just a minute. First, please tell me whether the PPT is visible or not.
Yes, ma'am. PPT is visible. Totally visible.
So this is a new slide to discuss the clustering by SOM. SOM is a special type of neural network. Okay. Hello, my student. You have a question, please. Hello.
Subhajit, ask question, ma'am. Subhajit, madam is asking question too. Ma'am, speaking.
Hello.
Hello. Am I audible?
Please. Welcome.
Yes, ma'am. I have a question. If I break clusters and its centers, then will it be possible to reduce the time? If I break a cluster into subclusters and calculate the center of those and combine them, average them,
I got it.
will it
I got it. Actually, you see, for any meta-heuristic algorithm, it is really difficult to find the time complexity because it is not actually deterministic. And there is and in each execution, even you may not have the same solution, but they will be very close to each other. Now, the time you just go through the algorithm, so you see in the first step, it is actually of the order of n, right?
Okay.
Because
Yes,
if n is the number of data points, okay, you need to find the distance of n from 3 clusters. So actually it is 3 into n. If I consider 1 unit time for finding the distance, okay, and you are comparing. And next is, once you know the data points of a particular, of all the clusters belonging to a particular cluster, then you can find easily the centroid. So this is just the average, right? This is just the average. So in this case, it depends on the number of, not always number of clusters actually. Okay. And this time, finding the distance, it is very simple. Actually, time is very important for some specific type of statement. For example, say comparison, right? So if you find the number of comparison, then you will see that which one is better with respect to the time complexity. Now, one thing, all these problems are actually which we use for meta-heuristic algorithm, they are generally NP-hard. So in this case, the time complexity is not very important. Sometimes we compromise with the accuracy for gaining the time. Okay, so for this type of applications, for example, neural network or some other learning, maybe evolutionary computing, we generally in our work we don't give more emphasis on the time complexity. If it is not was different, if my improvement is not was difference in regarding the time complexity. Okay. Hello.
Okay,
and for this problem, actually, to get the solution, it is very time consuming, and that's why the meta-heuristic we are using. Okay, the guiding principle such that we can get the solution maybe better, but we compromise with the accuracy, maybe little bit not the optimal one, but very close to the optimal solution. Okay. However, your question is nice. I get the chance to discuss at least these things, and very often we face the problem of a question of time complexity, which is not very important in case of meta-heuristic algorithm. However, of course, time is always important.
Okay, thank you.
Now, yeah. Now, the time is not enough. So really, I want to give you the idea how SOM can be used for clustering. And this is the architecture of SOM, and very simple. Just 2 layers are there, and these are the input layer, and these are the output layer. Okay, and number of input in the input layer actually the features, number of features or the number of properties of a particular sample. So in this case, actually, you know, the database for those students who are in preliminary level, who don't have the idea of pattern recognition, they don't know the term of features, okay, samples, data set, all these things. So in this case, data set means actually, you know, you have the idea of a table in the relational database, okay. So the content of a table, that is entity set, we call it data set, okay. And each row in a relational table, right, in a relation corresponds to one sample or one data, and all the rows, that is the entity set, is our data set, and the number of columns which actually gives the information of a particular entity, these are the features, okay. For example, I am Tandra Pal. Tandra Pal is one property, and my height is say 5 foot 1 inch. This is also one of my feature, and my age, my salary, my profession, these are all my features. Now for a particular problem, all the features of Tandrapal may not be required, okay. This is called dimension, that is how many features we need to process for a particular decision, okay. So in this case, this n is actually the number of features or dimension of the input data set, but not the data. This is n is actually the number of columns, right? In this architecture, we don't know how many such samples are there. This is I is only one sample or one row or one data, okay, and there are n such features for any particular sample. So in self-organizing map, this is the input layer, and we feed the data one by one. Say at first data I, that is I1, I2, In, all the features of I. Then say the next data or next sample is J, then we will give J1, J2, Jn like that. Okay, and in this case we have assumed that this is one-dimensional. The output node is one-dimensional, and there are we have assumed there are m such nodes. Okay, O1, O2, O3, On. So this is the input layer having n nodes, and this is the output layer with m nodes. Okay, so input is n dimensional and output is input is n, right, and output, the dimension is m, and all the inputs are connected to all the output nodes. That is, complete connectivity is there in self-organizing map.
Madam, interrupting you.
Yeah, hello.
Piyali Kormakar has a question.
Okay, Piyali.
While fitting, output layer same as the number of k.
I'm so happy. I'm so happy that PLE is actually started to think how SOM is will be used for clustering. Yes, PLE, you are 80% correct, PLE. Thank you so much. That is my objective, just to give you the principle of working behind a particular problem. You are correct, PLE. Partially, and more than 80% you are correct. Thank you so much. Now these are actually, we will give the introduction, that is the SOM, the characteristic SOMs, which will help us to know how it works, and also the algorithm. Okay, let us go. And of course, we will, for any network, we should remember the scientist who has devised it. This is Kohonen, one scientist in 1980, and it is self-organizing map, sometimes we call SOMs. Okay. Sometimes we call Kohonen's map. And actually, just you think that I am now seeing or viewing my scenery just which are in front of me, right? So this is the input space, and this is being sensed by our brain. Okay, and in the brain there are some region actually. So scenery are actually, you see, when I say something, then it is 3-dimensional, but it is being mapped to 2-dimensional. Okay, so multi-dimensional sensory input space. Sensory input space means, for example, in front of me, it is my TV, my flower vase, and all these things. These are the input spaces, right? Sensory input spaces. These are being, but what I am seeing, the 2-dimensional projection of it. Okay, so actually mapping is being done, and this is the principle of song. And the projection from sensory input, sensory means, for example, my TV or my table in front of me, inputs onto such map is topology conserving. What is topology? For example, in the flower vase, right, there are some no flower is there in my flower vase, only some leaves. So leaves are there, and under the flower vase the table is there. So you see the topology will be preserved. That is, the leaves always will be on the top of the flower vase, never it will go in the bottom of the table. That is, the topology in the input space will be preserved by the song. That's why my the ear, that's why when we see me, then you see the eyes are always near the nose. Eyes or nose are not in my feet. Okay, so this is called topology conserving, and this we try to follow in SOM also. Now this is the architecture, again, just to visualize the SOM in a better way. So you see, this is the input layer, and X is the input, and here N is the number of features. That is, once the input is given, right, this is one single sample is given, and in this case you see layer is 1. Okay, this is a layer, but 2-dimensional layer, that is a lattice. Is it clear? So it is 2-dimensional. In the first slide, I have shown you the 1-dimensional. Okay, so all this input, we are feeding it to the SOM, okay, and they are connected to all the output nodes. So this is the scenery, and this is our brain where it is being mapped. So ultimately, this scene will be mapped, and how to view, we can change the mapping according to our requirement. Okay, so you see the SOM output, a topology neighborhood. This is very important. First of all, you see the input nodes are connected to all the output nodes. These lattice is all the nodes in the lattice are the output nodes, and they are also connected with each other, though I have not shown all the connections, right, just to make the figure simple. So each input node is connected to all the output nodes, and all the output nodes are also connected to each other. Okay, however, these connections are actually will be updated. Who are actually near, that will be more connected, and who are far away in that connection, the connection will be weak. Okay, so just you see the idea of neighborhood. So here, if the points which are neighbor of a point also will be, there will be some corresponding points in the output layer corresponding to a node, which also corresponds to some input. I think it will be better in the with discussion. I think philosophical, yeah.
Interrupting you. Piyali Kormukar has a question. Is it mandatory to use a fully connected layer to fit always?
Yeah, not mandatory if you have the idea about the topology. You see, for example, in any neural network, we, for example, in multi-layer perceptron, we randomly initialize the weights. But if I have some idea, okay, about the distribution of the input, then sometimes we initialize it with some specific weights. And for this, another method are also there by which we can find the initial weight such that the learning by the MLP will be less. For example, say the K in clustering. In clustering, K, the number of centers are initially you choose random. But if you have the idea, then you can select accordingly, and in that case, it will take less time to converge. Okay? Hello?
Okay, madam.
So theoretically or ideally, all the output nodes are connected to each other, and that will also be weak and strong according to their mapping from the input or input space. I think partially you have understood. Really, it is very difficult to explain in such a short time, especially in webinar. Hello, organizer. Hello.
Yes, ma'am. Tell me.
Actually, my time is only 5 minutes, so I am trying to finish it early. So this is the concept of neighbor, which we consider in the output nodes. Okay, that is the lattice. Here you see, if we consider this, then these are the neighbors. That is for the pink node. The orange nodes are neighbor, right? So in this case, for this node, this is more close as neighbor than this as neighbor. That is my next door neighbor. Okay, and there is a next of next. So next door neighbor is more close than the next of next. That is my connection or relation among the next door neighbor is much stronger than the connection which is far away from me. Okay, this type of idea is there in SOM. And here you see, in this case we have assumed. Hello?
Yes, ma'am.
Yes, ma'am.
Someone actually has unmute, that's why noise was coming. Now it is okay. Now it is one-dimensional, right? In this case, we are considering one-dimensional output node in the SOM, and here we have shown all the connections among the, which PLE has questioned me, among the output nodes. But here I have not shown it such that it should be neat and clear, but actually these are there. Now in this case, you see these are the neighbor of this node, but if we consider this, these are the neighbor of this. Actually, this is also neighbor of this node, but in this case, the intensity or strength of the connection is much less. Now you see, now this is the two-dimensional output for SOM, and always we know the only two layers are there. So this is the output layer where the output nodes are in a two-dimensional array, and this is my input, and in this case we have assumed that there are three features. Okay, now you see one input is given and it is connected to all the nodes. Okay, so you see it shows only the connection with 4 nodes of the lattice, but actually it is connected to all the nodes. Now you see actually this connection represents the strength. This connection weight represents the distance of this node from this input node. Okay, these weights represents the distance of this node to this node. Now let us assume that this node is more close to the input than these nodes. So this is called the winner. Actually, SOM is competitive. Okay, so winner will be updated once it is closest. So this is the winner. So the weights will be updated in such a way it will be more close to the input. Okay, and in this case you see, sorry, I'm so sorry. Just a minute. Yeah. Hello, organizer.
Yes, ma'am.
Can I take 5 minutes more or not? Huh?
Yes, madam.
Okay. So in this case, you see, this is the winner. That is, this is the closest to the input node, and these are the neighbors. Okay, so this is not as close as to the winner. However, the weight will be updated of this node more than the updation of this node. Maybe the updation of this node, of the weights of this node may be done, but it is ultimately it becomes negligible. We actually the function we consider the function in such a way. Okay, now this is the Gaussian function, just to show that more the distance from the winner, less will be the change in the weight. So in the updation in the expression of updation of the weight, we actually use the Gaussian function, or you may use another function also, because in this case you see, if this is the winner, right, if this point represents the winner, then the distance of this point, okay, is less from the winner than the distance of this point from this. So we use this type of function such that the updation, the effect of updation will be much less for those neighbors who are much away from the winner. So let us go to the algorithm. So in this you see this shows the winner for which the distance is least, that is minimum. Okay, so in this case winner neuron K is the winner. Now this is, you see, we are updating Wi, and this is the previous and this is the new, and this is the learning rate. That is how fast it will run, and this function is actually we can use this Gaussian function or other function which represents our ID. Okay, so you see from this, that is less the distance, the updation will be more the distance, the updation will be less. So with time the owner will be more close to those inputs which are close, and and the neighbor of that winner will also be modified, but less. So I am not going. This is the input space approximation, that is with some, not only the clustering, but so many things we can do. So in this case, the rate points are the inputs, and in the same space actually, though the rate points are in the input space, and this grid shows the nodes in the output. So this junction, actually this is intersection, these are the node in the output, and ultimately you will see it represents the total input space. So input space can be approximated by this, and in this case you see the input is given in a triangular in a two-dimensional space. However, ultimately it is being mapped to the one-dimensional. So you see this can also be change of dimension, or can also be done by sum. Now another thing, you see just right, this is the input space approximation, and in this case you see the distribution is almost same. That's why these are the grids. Actually this change means the connection of the output nodes are being changed, and you see in this case the density here of the input space is same, and that's why density of the nodes here is also more. According, so density matching is also followed in sum, and in this case also this is the distribution. Small black circles represent the data points, and these blue points are the output nodes, and you see how the output nodes are being mapped to cover the input space, as well as the density is according to the density of the input space. And this is also another example, and this is also another example, but I would like to go to the clustering at last, but time is so less. Already we know that for example here for the input x1, right, this, that is O12 is the winner, and another for another input, you see this is the input x1 and this is the input x2. For input this is the winner, and for x2 the winner is the this is the winner, and in this case this is the neighbor, and for this case what will be the neighbor? is these are the neighbor. So using this principle, actually we can also this you see this is the input space and this is the output, and according here color shows actually their distance. Okay, so all the blue color inputs means they are close to each other, and they are being mapped to these output nodes, which are being also close to each other, making a cluster. So all the similar nodes here being clusters as a group here, all the similar samples are being clustered here. Okay, so thank you so much. My guess of time to represent this was not good enough. Wisely, I am not. It can be summarized more. However, thank you. These are the conclusion.
Sushman Chaudhary has a question.
Okay, okay. Let me see your face.
Dropout is used as a regularization measure to reduce
just a minute.
Training set.
Just a minute. Let me see your face. Huh? So this is very boring for me not to show, not to see your face. Yeah. I am audible and visible. Can I see your face, please? Switch on the video. At least who are making the question. Hello, Vijit.
Yeah. Sir.
Ha.
Yes.
Hello.
Okay, ma'am, I'm asking you. Drop out.
Oh, some problem. Okay, okay. Now, please put the question. Hello.
Hello.
You are not audible clearly. If all the participant mute the microphone, then I think right. Now the question, please.
Dropout is used as a regularization measure to reduce overlifting in training set.
Not only the dropout, actually to make a neural network or robust, there are so many things actually. We can regularization, all these things. Really, it is nice that you also know about robustness in neural network. I have some works on this, but this is not the right place to discuss. Okay, so if you have any question on clustering that I have discussed, then I will be more happy.
Thank you, madam.
Yeah, you can go to our website of NIT Durgapur. You will get my number, my mail ID. So if you are interested, please you communicate with me. Of course, I'll be happy if I can get the chance to discuss with you. Any other question, please?
Ma'am, some participants actually, participants want actually the slides. So is it possible?
Which slide, song or something?
No, ma'am, both slide is possible.
Oh, right. To send the slide to you.
Yeah.
Sure, I will send it.
Okay, ma'am.
I will send it. I have got the mail invitation. In that mail ID, I will send this PPT. So I'll be happy to if I can share.
Okay, ma'am. Okay, ma'am. Thank you. Gaurav sir, are you there? Gaurav sir, are you there?
Yes.
Okay.
Hello, madam.
Hello. Yes.
Yeah, I have a question actually regarding on this. Is it possible to judge that we get? Is it possible to judge that we get? Is it possible to judge that we get clustering results of how many sets? Means after how many sets we can get the result? Is it possible?
Set means cluster.
Yeah, how many cluster sets we can get that result? Is it possible to predict in before that? Means like we can get the results.
No, if we use k-means clustering, actually once given the data set, it is not possible. If it is not, if I plot it, it is in 2D or 1D or even 3D, then we can guess how many clusters is there, even by rotating the data set. But if it is more than that, it's very difficult to get the idea how many clusters. So actually, if you go through the index, clustering index, right? There are so many clustering index measures devised by expression by different researchers, and there are so many works on clustering index, and people have used the clustering index, the concept of clustering index, to find the optimum value of k. But this is now the beyond of my discussion, so I will tell you, please go for clustering index, which is a measure which we will use for finding the optimal number of k.
Okay, ma'am. Okay, then Rakesh sir, shall I conclude?
Yes,
Hello.
sir. Yes, sir.
Again, I would like to share my PPT as well as my mail ID as well as my number. So if you are interested, you can communicate. I'll be happy. Oh, nice.
Yes,
Thank you so much. Please, you send it in my mail.
Yeah, ma'am, here it's a small
Really?
piece of gratitude from our side. Hello.
Yeah.
Am I audible? Yeah.
Yes.
Ma'am, this is a small piece of gratitude from our side.
Thank you so much. Thank you so much. I am really happy. The students are so nice. Really, I am happy. And with the teachers, always, if I can discuss with the participant, with the students, or with the faculty, we are always happy. So once I get the invitation, I have accepted it. Okay,
Wow,
thank you.
Wow, it's really a good digestion session of clustering and cluster analysis of machine learning after lunch. Thanks a lot, madam, for your eloquent
Most of the
explanation.
people are already they're sleeping, and it is nice. I
And-
also, after lunch, always I sleep in the class. Okay,
Thanks
thank
a
you
lot,
so
madam,
much.
for your eloquent explanations and interactive views regarding such unsupervised learning method in machine learning. I think this
Right.
will re-orchestrate the cluster views and opinions about this motive by drawing references from datasets consisting of input data without labeling particular responses.
Nice.
Now I am passing
Nice.
to Rakesh sir for next session.
Okay, so I am leaving, right? Thank you. Goodbye.
Thank you, ma'am.
Okay, thank you, Gaurav sir. Bachu sir, are you in our system? Bachu sir, am I audible?
Yeah.
Okay. Okay. Mr. Bachu Pal is currently working as an assistant professor of computer science at Vidyasagar University. Mr. Pal did his MSc and MPhil in computer science and pursuing his PhD from Maulana Abul Kalam Azad University of Technology, Macau, in computer science and engineering. He got some prestigious awards like first class first in BSc Computer Science, first class first in MSc Computer Science. He also got the gold medal for best student among science and another gold medal for best student among all academic departments in his postgraduate. Yes, so many working experience in different fields of government sector, like as an officer in block development office, central government, postal department, school education department. In higher education department, he served as assistant professor in computer science in West Bengal Education Service through Public Service Commission. Later joined as assistant professor of computer science at New Alipur College through College Service Commission. His research interest is machine learning and deep learning on automatic speech recognition. I am kindly inviting sir, please give your valuable lecture on this topic and please start your session.
Okay. At first, let me check my audio. Am I audible? Am I audible?
Yes, sir. Yes, sir. Yes, sir. You are audible, sir.
Thank you. Let's start. Is my screen visible?
No, sir. Till now, Yes. Okay, sir. It is visible.
Okay, thank you. Good afternoon. Myself Bachupal. I would like to thank the principal and the organizing committee. Hello, am I audible? Hello.
Yes, sir. Yes, sir. Audible.
Okay. I would like to thank the principal and the organizing committee member, Department of Computer Science and BCA, Debratana Khudiram City Mahavidyalaya, Paschim Medinipur, West Bengal, for inviting me on this virtual platform to deliver a lecture on international webinar on emerging trends and advances in machine learning. And today I will discuss the topic recommender system. These are my list of content. I'm not going details here. So next, if we observe that in last 2 decades, a huge number of people who like to buy products from several e-commerce companies like Amazon, Flipkart, Snapdeal, eBay, Netflix, etc. And this is called online shopping disasters. On the basis of their shopping, they give a rating. For example, I matrix. This matrix is called a demographic rating. For example, here 4 items. The user Jane is happy with the item 1, but unhappy with the item B. And item 4 is not bought by Jane. Other users like that. Now, the recommend engine or a recommender system recommend a list of new items that a new user or a user that may be in. So there are several questions. The recommender system will find the answer. For example, when we want to buy a product or any planning a tour or buying any insurance, we get some suggestion from expert. Instead of expert, we take the suggestion some machine learning based recommender system called recommender system. Which mobile set should I buy? What is the best holiday for me for my family in the neighborhood? Education and policy. Should I find in interest buying product? Which degree and university recommender engine will give the. Now come to the technical recommender system. A recommender system is an information filtering technique which provides the users with the relevant with which the user may be interested in. In another way, we can say that a recommender system refers to a system that is capable of predicting the future preference of a set of items for a user and recommend the top set of items that the user might bought in the future. In very general way, these recommender systems are algorithms or a group of algorithms suggesting the relevant items to the user. The users, this item may be movies to watch, text to read, or products to buy, anything depending on the industries. Now come to the application area. Here I have shown only 4 application area, but actually there are a lot of application area of recommender system. Almost all e-commerce sites use the recommender system. For example, the Netflix is a movie rating selling company and mostly used in North America and UK. And among them, 60 to 70% users buy the movies according to their recommender algorithm. Amazon is a popular e-commerce company. They selling huge number of products and they use this recommender system. Another is LinkedIn and Facebook is another type of social media network, social siting networking. They use also recommender system. And Pandora is one music selling company. Based on their rating of the users, they sell music. These are the commercial
Sir, I'm just interrupting you. Your voice is cracking now. Sir, your voice is cracking now.
Okay. Hello, hello. Not audible. Rakesh?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Yes. Yes. Tell me. Yes, tell me. Hello.
Yes, sir. Yes, sir. You are audible.
Hello.
Sir, you are
Okay.
audible.
May I continue?
Yeah, yeah.
Okay. May I continue? Okay.
Yes, sir. Yes, sir. Continue.
Now, what
Yes,
are
sir.
the? Okay. Thank you. Thank you, Rakesh. Now, what are the data of the recommender system? The data, like any traditional machine learning algorithm, the most important is the data. So it is necessary to extract the data for the recommender system. Basically, there are three types of data. The first one is explicit data. The second one is implicit data rating, like 5-star, 10-star, this type of rating. And when we buy the product, we give some rating according to my satisfaction of the product. Feedback is the comments like happy, unhappy, comment like that. These are called feedback. The third one is demographic. In my first slide, I show the graphical presentation of like happy, unhappy, or like, dislike, this type of graphical presentation. And physiographic are the third type of data. It's a geographic based rating system. And short span of time, there does not need rating or implicit data. There is no direct rating by the user, but the number of clicks, number of page visit, the number of times a song was played, the number of times the movie was watched, this type of rating are extracted by the recommender system, and this is called the implicit data. And third one is product information. Third one is product information, like product attributes, product taxonomy, product characteristics, product description. These are the more useful data in recommender system, three type of data. Now, types of recommender system. Basically, there are two types of user in a recommender system. One is personalized user called registered user, whose database is known to the recommender engine. The second one is non-registered user, whose database is not registered, or whose database is not known to the recommender engine, called non-personalized or non-registered user. For both of the user, there are three types of recommender system. The first one is collaborating filtering, the second one is content-based recommender system, and third one is hybrid recommender system. Collaborating filtering is a method finds a subset of users who have similar tastes and preferences to the target user. That means my taste and my friend's taste almost match, and collaborating filtering find this subset of users who have the similar taste. And this is also of two types, user based, and the second one is item based. The second one is content based recommender system. The content based recommender system are like the content parameter, depending on the content parameter rather than on the user's opinion. There needs some natural language processing for this type of recommender system to get the rating from the content parameter about the item. The third one is the hybrid recommender system. For both of the above two recommender system, like collaborating filtering and content-based recommender system, there are some problems. To overcome these problems, the third type of recommender engine was developed to recover this type of problem. Now, today, as the time is limited to me, so today I will discuss the collaborating filtering. Because collaborating filtering is most useful technique for recommender system. Almost all e-commerce site uses this policy or this algorithm. Collaborating filtering is a technique that can filter out the item that a user might like on the basis of the reaction of similar user. For example, look at this picture. This is an input user. At first, the similar input user and a subset of users called community users are find out some algorithm or recommender engine then the recommender engine will give some suggestion to buy this set of products, top set of products for the input user. Once again, I am telling this is input user. First, the recommender engine will find a subset of users, a subset of a group of users who have similar taste with the input user. That means my taste and my set of group ends who have the similar choice, or my like and my friends like are almost same. The recommender engine will find that this group of users, and then according to this choice of this group of users, the recommender engine will recommend the item. Now, this collaborating is one is user-based collaborating filtering, and the second one is item-based collaborating filtering. First, user-based collaborating filtering. Let's look at this picture. Consider there are three users: user A, user B, and user C. And there are four items: item 1, item number 2, item number 3, item number 4. The user A already bought all the four items. User B bought only the item number 2, and the user 3 bought item number 2 and 3. Now, some mathematical formula, the similarity between user C is mostly matches with the user A. That means this user's taste and this user taste almost the same. Then the recommender engine will recommend these two items, that is item number 1 and item number 4 for the user C. Now, how this similarity is measured? That is the similarity between two input, how is computed. One is the standard similarity measure is the Pearson correlation coefficient. Pearson correlation coefficient between two user A and B is this formula. Formula is summation the rating of user A on the item P minus average rating of the user A multiplied by the rating user B on item P minus average rating of the user B divided by the square within square root, the summation of the square of this element and the square of this element within the square root of this element. So, for example, let's consider once again, and the possible values of the similarity between A and B within the range -1 to 1. That means when the similarity between A and B is 1, that means the taste between input user A and B almost same, and the similarity between Hello?
Sir, are you there? Yes, sir. Are you there?
Yes.
Okay, sir. Okay, sir.
Yes.
Continue.
Am I audible? Clear? Okay. Thank you.
Sir, sound is properly not clear.
Sound is not clear. Okay. Let's just wait a few seconds. Now clear?
Yes, sir. Totally
Yes,
clear.
sir.
Okay. Thank you. And the possible values of the similarity between AB within the range -1 to 1, where 1 means the similarity between the input user A and the input user B are almost same, and the -1 means the similarity between input user A and the input user B are opposite. That means the user A taste and user B taste are opposite. Now look at the example. One example here in this rating matrix, there are 5 items. That is item number 1, 2, 3, 4, and 5, and 5 user. And what will be the value of item 5 for the input user Alice. First, to find this question mark, the predictive rating for Alice on item number 5 will be first the similarity between the input user, this is the input user, and these are already rated. So the similarity between the input user Alice and the rest of the user are each computed in the previous using the previous formula. So the similarity between the Alice and user 1 is 0.85, and similarity between Alice and user 2 is 0.0, and the similarity between Alice and user 3 is 0.7, and the similarity between Alice and user 4 is minus 0.79. And I am giving here one computation, one mathematical derivation for 0.85. How 0.85? Simply we can say that there are four items Alice and user 1 have rated, that is item 1 to item 4, both 4 items have rated. So in the numerator there are 4 product terms, these 4 product terms, and within the product term there are 2 multiplicand term, this multiplicand term for Alice and this multiplicand term for user 1, and this is the average rating for Alice, that means 5 plus 3 plus 4 plus 5 divided by 4, that is this 4 is for Alice average rating, this 4 is for average rating for Alice, and this individual component, and this component is the individual component for Alice. This 3 is this 3, and the second term is the individual component for user 1. In the denominator, and the similar term, the square of this term, sum of square root within the square root, the square of this term, this is for user Alice, and this is for user 1. So this term is equivalent to 0.85, and similarly the similar values are computed using the same formula, only these values will be replaced. Now what will be the rating value? The predictive rating function is the average rating for the user A plus summation of similarity between input user and the rest of the user multiplied by rating for user B on item P minus average rating for user B divided by similarity between input user and the rest of the user. For example, in previous example, here we consider 2 similarity highest similar coefficient value, Pearson correlation coefficient value, that is 0.85 and 0.7 in our calculation. So predictive rating on, what will be this value? So this value will be the average rating for user Alice 4 plus 0.85, that is the Alice, the similarity between input user Alice, the input user Alice and the user 1 is correlation coefficient is 0.85 into 3 minus, that is rating on item, this item rating for user 1 is 3, so 3 minus 2.4 is the average rating for user 1 plus 0.7 into 4 minus, that means 4, this 4 is equivalent to the rating of user 3 on item number 5, 4 into 4 minus 3.2 is the average rating for the user 3 divided by sum of this term and this term. So this value is equivalent to 4.69. Therefore, the value of the item, the rating value for item 5 for the user Alice will be 4.69. Another similarity measure is the cosine similarity measure. The cosine similarity is the summation of the first component, the individual component of the first user and the individual component of the second user divided by standard deviation of first user and the standard deviation of the second user. For example, consider this example. There are 4 items and 4 users. What will be the value of this question mark? So to find this question mark, first we find the cosine similarity using the previous formula. That means this using this formula. So this cosine similarity is measured using the formula for the cosine similarity between Nathan and Joe is 0.99. So how this 0.99 is computed? I have given here one formula. That means that is 5 cross 5 plus 2 cross 1 plus 5 cross 5 divided by sum of the first component, that is for user Joe, that is 5 square, 2 square and 5 square, into within square root the sum of the square of this the user Nathan, that is 5 square, 1 square, 5 square. This value is equivalent to 0.99. Similarly, the cosine similarity for Nathan and John is 0.64. Using this same formula, replace these values, and similarity between Nathan and L is 0.91. Now, what will be the rating of this value? So this value, that is the prediction rating for the Nathan, for the user Nathan on the item Titanic, will be, so this cosine similarity, that is correlation coefficient, into the rating for Joe, that is 4, plus this coefficient into the rating for John into 3, plus this value into the rating for L on Titanic is 2, divided by sum of these all 3 components. Therefore, this value is equivalent to 3.03. Now, in simple, we can say that user-based collaborating filtering supports user B to item 4 rating is 5 and user A to item 4 rating is 1. Then what will be the rating for user A to item 4? The values for rating A for the item 4 will be 5 into the similarity between input user A and B plus 1 into similarity between user A and F divided by the similarity between user A and B and similarity between user A and F. This is the simple formula for user-based collaborating filtering. Now come to the second type of collaborating filtering, that is item-based collaborating filtering. Look at this picture, the second type of collaborating filtering. As previous, there are 3 users, user 1, 2, 3, and item 1, 2, 3, 4. Here user A bought these 3 items, item 1, item 3, and item 4. User B bought item 1 and item 3. User C bought item only 3. Now, instead of calculating the similarity between the user, here we calculate the similarity between the items. That means the similarity between this item, this item, this item, this item, this item, and this item will be calculated. And assume some standard statistical formula or mathematical formula. Assume this item is mostly matches with the item number 1. That is item number 3 mostly matches with the item number 1. So the recommender engine will recommend to buy this product, that is item number 1, to buy for the user user number 3. User number 3, because user number 3 is bought item number 3 and item number 3 is similar to item number 1. So item number 1 will be recommended for the user 3. This is the basic idea for item-based collaborating filtering. Here, what will be the, as previous example, similar to the previous example, what will be the value of this question mark? The value of this question mark will be that the similarity between item 5 will be computed, and assume that this item is similar to item number 4 and item number 1. As here the similarity, these values are computed with the this rating, and most of the voting is measured into account. Therefore, item number 1 and item number 4 are most accurate with the item number 5. Now, how item-based similarity will be computed? The item-based similarity measure is the cosine similarity measure. The cosine similarity between the input vector, here AB are not user, here AB are 2 items. So similarity between item A and item B is the dot product of 2 vectors divided by standard deviation of the first item and the second item, dot product of the second item. And using some adjustment of the first, this equation, the adjusted cosine similarity is computed using this formula. Here, just instead of squaring the individual element, here we subtract the average rating for individual user, and this value is taken into our account for better efficiency. So now, what will be the predictive rating function for the item-based collaborating filtering? So predictive function on a item P for the user U will be sum of the similarity between two items, item I and item P, multiplication by the rating for a item I for the user U divided by the similarity, sum of the similarity of between two items, item I and item P. Let's look at example. So consider user A to item 2 rating is 1 and user A to item 3 rating is 2. Then what will be the user A to item 4 rating will be? So what will be the rating of A to item 4?
Sir, you are not audible.
Yeah, I'm watching the YouTube. There are so many comments. I'm not audible now.
Yes, sir. Yes, sir.
Audible? Now audible?
Okay, sir. Yes, sir.
Okay. So what will be the rating for user A on item 4? This will be 1 into the similarity between the item 2 and item 4 plus 2 into similarity between item 3 and item 4 divided by similarity between 2 and 4 plus similarity between 3 and 4. For example, consider what will be the value of this question mark. Here there are 3 items, item 1, 2, 3 and 3 users Sam, John and Tim. So this value will be 2 into the similarity between apple and toast and plus 4 into the similarity between milk and toast divided by similarity between apple toast plus similarity between milk toast. Now, what are the problems of collaborating filtering? There are popular problems called cold start problem. That means an item which is not rated, which is new to the new item which is not yet selling. So there is no such rating value. Similarly, a new user whose database is not known to the or who never bought any product. So the recommender engine will suffer a serious problem to suggesting him which product is suitable for him. This is called cold start problem. Another issue is sparsity, that is the rating matrix. There are so many users does not give any rating value, so this value will be a sparse value called, we know that this is called sparse matrix. The matrix with more than 50% element will be null value, that is 0 value. The fast rater is another issue. Fast rater means is a cold start problem, similar to cold start problem. And popularity bias is another issue. It cannot recommend an item to someone with unique taste. And scalability is another problem, as the number of user and number of item will be increased in the system, then a web-based recommender system will suffer a serious scalability problem. Now, in the conclusion section, we can say that for a content-based recommender system, there needs some PCA, that is for dimensionality reduction, and for handling the input data sparsity, we need some matrix factorization, that is singular value decomposition. Overfitting is another issue to handle. Overfitting is a problem because when your training data set is sufficiently accurate, but it fails to recognize for a test data set, and content-based recommender system increase the content number of parameter, then complicated model, then the model will become complicated, and prediction accuracy is proportional to the number of content attribute. For collaborating filtering, recommender system. This is easier to implement and more accurate system. Now I'm giving a demo. Let's look at a demo. Am I audible?
Yes, sir. Yes, sir.
Okay. Okay, let's wait. Is my screen visible?
Yes, sir. Yes, sir. Yes, sir. Your screen is visible.
Okay.
To all of us.
I'm giving a demo for collaborating filtering. This is a movie rating recommender system or movie selling recommender system. This is also available in IBM Watson Studio. In this example or demo, I have done basically 3 steps. The first one is data acquisition phase. The second one is pre-processing, and third one is collaborating filtering implementation phase. In my data acquisition phase, actually this platform is, I'm missing this. This is Jupyter notebook that is from Anaconda, one of the working environment in Anaconda. So let's, in data acquisition page, you can download this data from GroupLens movie dataset, and this data, when you download this dataset, you will get a zip folder, and within the zip folder, when you extract it, you will get 2 CSV files. The first one is movie CSV, and the second one is rating CSV. In the movie CSV, there are almost 40,000 movies, and in the second database, that is rating CSV, there are almost 10 lakh, more than 10 lakh records for 270,000 users on individual rating for the different these 40,000 movies. And this data set is prepared before 2017, extracted from the Netflix, the movies from the Netflix. Now the next page, the pre-processing page, I have export my all the libraries specifically for pandas and NumPy. If I run this code, here we will not get any output. And in the next phase, next cell, I have read the movie CSV data file into the movies data frame and the rating CSV file into the rating data frame. Let's run the code. Okay. Let's display some of the rows for the movies. This is movie ID, and this is the title, and this is the genus. Genus is the type of movie, that is comedy or action movie or this type of genus. And in the next cell, I have omit this ER from the title and adding a new column ER at the end of the table. Let's run this code and display few rows of the movies data frame. Yes, from the previous table, look at this. This ER is extracted, is removed and added in the new column. Let's drop this genus column, run this code, display this code. Actually, this genus is omitted, and I drop this column, and this is not necessary for my recommender system. Now come to the rating matrix. Let's display few rows of the rating matrix. Yes, this is the rating matrix. That is user ID, and this is the movie ID, and this is rating. This rating actually 5-star rating. That means from 0 to 5, and this is the time step. And this value actually indicates the when the user review it. Let's in the next column. Let's drop this column, and this is not necessary for my recommender system. So now let's display this column, and this from the previous table. Let's look at this. Here is the timestamp is omitted, that is dropped. Now in the third page, that is implementation of collaborating filtering. Look, consider a user, a input user who have watched these 5 movies, that is these 5 movies, and the user have rated like that. For the first movie he rated 5, like that. The second movie 3.5, 2, like that. Now my task is how the recommender engine will recommend the which movie the user might be interested in. So at first, to do this, at first I have added the movie ID, a new column movie ID according to this set of movies. So in the next cell I have run, and the movie IDs column is added here. Here is not movie ID, but in the second here is movie ID is added. Let's find a group of users who have watched the same set of movies. That means these movies are already seen by the set of users who have. Now let's find this subset of users. So let's run this code, and I have only few rows I have displayed here. This subset of users, that means these users have watched these movies. Let's group them according to some user ID. For a particular user ID display, for a particular ID, let's consider the user ID 1130 display. That is for user ID 1130. He watched this all set of movies, and his rating is he or her she's rating is like the her rating are like that. Now let's sort this user ID according to user ID in the ascending order of user ID. So let's run the code. Wait. Okay, wait, just it is running. This star indicates that this code is running. Okay, let's display for first 3 user groups. So first 3 user groups, that means for input user and the user 75 almost same set of movies and watched, and the user ID 75's rating are like that, and the input user and the user 106 are almost the similar test, and for user input user and the user ID 686, I have displayed only 3 subset of users. Now let's, for here almost 2,70,000 users, such user groups. So let's consider, for time consuming, as very time is limited, let's consider for first 100 subset of users into my account. Now find the correlation coefficient, the Pearson correlation coefficient, as I discussed in my theoretical portion. Display as the Pearson correlation coefficient for the input user and the first 100 users. Let's run this code. Let's display, and this indicates the similarity between the input user and the user ID 75. The coefficient values is this. Similarly, for second, the Pearson correlation coefficient for the input user and user ID 106 is 0.5. Let's display this into a tabular form. Let's run the code, and this means the similarity index indicates the similarity, the Pearson correlation similarity between the input user and the user ID 75. Similarly, the input user and 106 is the Pearson correlation is this, like that. Now let's take the first 50 values, highest 50 values, that is the highest similarity index 50 values is considered for calculation. So we sorted these values, these similarity index values are sorted according to the highest values or the descending order. So these values, let's find the subset of users who have watched these movies and their corresponding movies and rating is display. Wait, that means for a particular user ID 1, 2, 3 to 5. He have watched this set of movies and his similarity index like that, and his rating is this. So let's, in the next cell, next a new column is added called the weighted rating. That is, the similarity rating is multiplied by rating. Let's run the code. That is, a new column is added, that is weighted rating. This value is equivalent to the similarity index, and rating value is multiplied. Let's sum the sum of the individual the similarity index and weighted rating and group them into the movie ID. So this means that for a movie ID, the sum of the similarity index value this, and the sum of the weighted rating is this. Now look at, suppose the movie ID 1 is rated by 100 user and movie ID is rated 2 is rated by 50 users. So to scale this range into a normalization factor within the range 0 to 5, let's divide this value, that is sum of weighted rating divided by sum of similarity index, and this is called weighted average recommendation score. Let's run this code. This is the weighted recommendation course. This score is the this value divided by this value, and let's sort this value according to the highest value of weighted average recommendation score. Let's run the code. That is the highest according to the weighted average recommendation score is sorted according to the highest value of, from the highest value of, and the corresponding movie IDs are this. And let's consider the first 20 movies, and these movies are interested with the input user, and let's display these movies. These are the movies ID and their corresponding movie title. That is, let's run the code. This movie set is interested for the input user. That means my recommendation system who have watched movies, that means who watch this set of movies, the recommender engine will recommend for the input user to watch this set of movies. That means this set of movies the user might be interested in. Look, now I'm stop sharing my screen. Now, okay. Okay, that's all. That's my session. Thank you. Now the question and answer session. Okay.
P.Ali Kormakar has a question.
Yes.
If cosine similarity is -1 means opposite and 0 means not similar, what is the difference within this?
What question? Repeat the question, please.
Cosine similarity is -1 means opposite, and
Opposite,
0
yes.
means not similar. What is the difference within this?
0 means there is no relation. That means 0 means that the test between input user and the new user, already existing user, there is no similarity. 0 means there is no similarities. There is no, that is neutral test. That opposite means if I rate for a particular item 1 and my friend is rate that item 5, this is opposite, that is -1. And 1 means if I rate 5, then my friend also rate 5. And 0 means that means neutral, that is no relationship between the input user and he or she might be rated it 1 or 2 or 3, that is difference. Yeah.
Thank you very much, sir. Habib Peske has a question. Online education field, how can more benefit using machine learning?
What?
Online education field, how can more benefit using machine learning?
Actually, this is not field in this field. This is a different issue. So I'm giving her a recommendation system. Online. Please repeat this question.
Online education field, how can more benefited using machine learning?
Online education, how can
Sir, Sir, I'm telling you.
Yes, sir. More
Online
benefited using machine learning. Online education. I think that
Yes.
there is no relationship between online education or online education system is truly through web-based education system, and already there are some videos that some text-based PDF, some and user can extract this, download this. For face-to-face communication, there needs some more efficient for clearing any doubts. So in machine learning, we can say that it will be helpful for some algorithmic approach to questioning, answering, like question answering, like any PPTs, like that. So this is not relevant this field. This is recommender system. I use this recommender system. Okay.
Sir, I have a question.
Yes, yes.
Sir, you have showed that the prediction matrix in which the neighbor size was limited. But what if the neighbor size is limited or beyond some range? Then what will be the proposed solution of that?
Yes. It's very good question. It's very good question. For this, when neighbor size is not limited, then some machine learning algorithm will be implemented, like clustering or like KNN classifier, some type of matching matrix to find the subset of users. It's clear?
Yeah, sir. So thank you very much, sir.
Okay,
sir. Okay, sir. Piali Kormokar has also a question that similarity be used in calculating sentence similarity, basically sentence embeddings.
Yes. I can understand your question. It's very good question. Another good question for text-based. Actually, this is sentence-based recommendation system is very content-based recommender system. I have not discussed here. Even I am speaking the answer for content-based recommender system. There needs some natural language processing, like that number of word repeated. There needs some TF IDF type of calculation, called term frequency or inverse document frequency. That is the most important feature, and that value is indicate the rating matrix and into account. And then first the NLP is used for extracting the rating matrix using some formula like TF, term frequency, inverse document frequency, and then the cosine similarity is measured. Okay.
Okay, sir. Thank you. Santanu Mondal has also a question. Can we use recommended system gaming for find the shortest path?
Yes, what?
Sir, I am repeating the question once again. Can we use recommended system in gaming for find the shortest path? Sir, am I audible?
Yes, audible. For gaming find the shortest path.
Yes, sir.
Actually,
they've asked the question.
Gaming not possible. Actually gaming suggestion to game this type of game is suitable for this user. This type of game is user might be interested in. Actually, when we search a item, that type of item will recommend it and is visible when we surfing our Facebook or any watching any movies through online. This type of adding like that. So for gaming, there is not shortest path. Actually, this is required for this recommender system will give the suggestion. Okay.
Okay, sir. Okay, sir. Gaurav sir, are you there? Gaurav sir?
Yes, I have here looking for another question. I'm giving the answer. Is there any advantage of the cosine similarity, as I have tried to cosine similarity to calculate sentence similarity? Yes, Piali Kormokar have a question. Actually, For cosine similarity, there are two types of similarity I have discussed. There are so many other similarities matrix, similarities calculation like J-cut coefficient, etc. is available. For content-based recommender system, there needs some previous model-based, basically used for model-based recommender system. The second type of recommender system, that is collaborating filtering, is more useful for memory-based, called memory-based recommender system. This is useful for when the input matrix is given, already given, then this type of recommender system is very useful. It's clear clearly? I hope that you will clear. Okay, that's all. Thank you. I'm just now stopping my screen. And thank you, organizing committee, for inviting me. Thank you. Thanks a lot.
Okay, Gaurav sir.
Okay, what a day of learning curve. It's rationally seeming like our weather today. Sometimes hot and it's raining sometimes. From the effective relation of data input sets to real object-based data analysis according to system specifications. Probably in context or verbally, that is why the machine learning resides in every approach of modern computing techniques. Thank you, sir, from our whole team for your valuable numerical formula-based perceptions and relevant application-oriented modus operandi regarding a system that is capable of predicting the future preferences of a set of items for a user and recommend the top items. Thank you.
Thank you.
Thank you, everyone. Thanks to our audience also for participating the entire session for today. We will meet once again tomorrow to discuss a lot more promising aspects of machine learning. Thank you all.
Sir, wait.
Okay.
Sir, just wait sometimes. Sir, Somo sir, are you there? Somo sir, are you there? Sir, kindly, sir, share the certificate. Okay, sir. Sir, shall I share my screen?
Yes.
Okay.
Sir, here is a small
sir,
piece of
it is
gratitude from our side.
Oh, that's very good. Very
Thank you
nice.
once again.
Sir, we are very much grateful to your informative session. It is just a token of gratitude from our end. Thank you, sir.
Okay.
Okay, sir. Sir, Gaurav sir, conclude the session. Gaurav sir, are you listening? Gaurav sir, are you there?
Hello.
Gaurav sir.
Am I audible?
Yes, sir.
Yeah, thank you everyone. Thanks to our audience also for participating in the entire session for today. We will meet once again tomorrow to discuss a lot more promising aspects of machine learning. Thank you all.